side of things, sociology, history, English, philosophy, stuff like that. But I'll help you guys on anything I can, and I'm willing to learn with you, help you that way. So if you need me, I have flyers, which like that. There you are. So if you have any questions, feel free to come by the DSPS office. Okay, thank you so much.
Yeah, nobody read the paper, so they may pick you up on that.
All right. Thank you.
Is anybody on? Not right now. Perfect. Thank you. Okay, so we talked about empirical formulas, right? Yeah. So what is an empirical formula?
The simplest multitude of the formulas.
Okay. Give me an example. Help me understand.
E6H12O6 down to CH2.
Okay. Sounds good. Okay, so a compound is determined to contain 5.31 grams of chlorine and 8.40 grams of oxygen. What is the empirical formula? You say cobalt?
Can you please?
I said a compound is determined to contain 5.31 grams of chlorine and 8.40 grams of oxygen. What is the empirical formula? Come on now. It's a Monday. You can't give me that attitude already.
We're in some moles.
So we need to use moles as the gateway.
Yeah.
Oh, the one thing that you need to write down. Oh, right. That's a good job. Okay, so how do I convert the chlorine into moles?
You have to know how much one mole is?
We need the molar mass of chlorine.
Yeah.
So what is the molar mass of chlorine or the atomic mass of chlorine? What was that?
35.45.
35.45. Okay. So am I going to divide it by it, or am I going to multiply it by it, or am I going to pick my nose with it? What am I going to do?
Divide.
Divide. Okay. Okay. Somebody do the heavy lifting.
Or 9.
Wait,
Do you want to round it? Because it's 0.1497.
said it's 0.1497. And what will we round it to? How many sig figs should we have?
3.
3.
So it'd
Okay.
be,
Okay. The next thing we're going to do is do what? Same thing for oxygen. What is the molar mass or the atomic mass for oxygen? 16. So we're going to multiply or divide by it. Okay. 3 sig figs. Okay, next step.
Divide by the smallest.
Right, that's smallest.
Point five.
Okay. So what are we gonna do now? We need to find a whole number. Okay, so we multiply by what? 2. Multiply by 2. Both numbers or just? Okay. Good.
Right out the formula.
Formula down here.
Point five, I can see good.
Oh, sorry.
Now you
My head's in the way here.
can.
Yeah, I know. Okay, questions? Any questions? Any concerns? Pretty straightforward, right? Okay, so that is empirical formulas. Are you guys feeling comfortable? Good. Okay, so this is just a schematic to kind of help us understand. If we're given the mass, we have to use moles. We have to get to moles. And then we're doing a moles-mole comparison of the 2 elements, or 3 elements, or 4 elements, depending on how many compound that we're looking at. And then we're going to divide it by the smallest number. And then that's going to give us that ratio. Now, if that ratio is whole numbers, we're good to go. If it's not whole numbers, right, then we're going to have to multiply something to make them whole numbers. Questions? Okay, good. I like it when there's no questions. That means that you guys have an understanding. We've talked about when there's percentages, when we're using percent mass, right? We know that we have to assume that we have 100 grams, right? And then we go through that same process again. So here's an example. A bacterial fermentation of grain to produce ethanol forms a gas with a percent composition of 27.29% carbon and 72.71% oxygen. What is the empirical formula of this gas?
Have to find out how many grams of carbon you have and how many grams of.
Okay, so how would I do that?
Well, you can assume that we add them together, the two numbers of percentages together to get 100. So maybe 100 grams.
Okay, so if we have 100 grams, okay,
And well, if we know we have 27.29% of 100, which would be converted directly to grams.
okay. So you're saying I could change that directly to grams?
Yeah. I hope so.
$27.29. grams. And the atomic mass of carbon? 12. Dividing it by 12 grams per 1 mole. Heavy lifting. Okay, and what about the next one? So again, assuming that we have 72.71 grams of oxygen. Oxygen weighs
60.
Okay.
4.5.
mixed equation we have for this.
4.
4. Okay. How many do we have for
3. Wait, no,
3
no,
for the
it's
top
supposed
of
to
it?
be- Yeah, 2 per.
You need
Change
2,
it to 2.3.
2.3?
Yeah.
Well, how did you get 2?
Put in maybe the 4 on top.
So how do you get 2 sig figs? It'll be 4, right? 4 sig figs. Right, because when you're using the masses from the periodic table, they're typically round, this is a round number, right? So you don't want to use that. You don't want to use the mass from the periodic table as significant numbers. You use what's given. So you have 4 sig figs. So 2.274.
Oh, sorry, actually.
Okay, and then the bottom. Said 4.
Yeah, it's supposed to be 4.
It's
On the top.
4.544.
Yeah.
Okay, top is supposed to be a 4.
No, that's fine. That one's fine.
That one's fine. Okay, bottom one,
0.544.
4. Yep.
So like, for example, she did it like on the board, like just dividing by 12, but if you do the actual mass on the periodic table, it gives you like more.
Numbers.
Yeah.
So if you just use the number from the, say you do the round number.
I used the whole like the 12.011 and I got that and she got 2.274.
Yeah.
So,
What would you want?
so either way, it would end up working, it's gonna work out about the same.
Okay.
Because if you divide by the smallest, use that 4
That's right.
or that 2, it's gonna end up working about the same.
Okay.
So. And that is the thing about rounding, right? So we divided by the smallest number. So we said 2.274. I mean 2, sorry. And then you divide this one by said number. I'm assuming the other one is equal to 2.
Yeah.
see. So if we divide it by 2 point, the first one would be 1, and then the other one would be approximately 2, would be like 1.99. So we'll just round up. Okay, questions? Concerns?
So if it is at like 1.9, it is okay to round it to the nearest
Yeah.
whole number.
If it's 1.9, we can round to the nearest whole number. If it's 1.8, that's when.
Then now we would have to find the integer and multiply it.
That's So you guys all remember the table and everything like that, right? We went over it. 0.5. and
Oh, yeah. Oh, yeah.
Okay, so this is just a fermentation tank. And so when they're making wine or whatever alcohol they're deciding to make, they have a fermentation tank, and you'll notice that there's this nice little vent that allows the carbon dioxide to escape, because that's one of the byproducts of fermentation. Or they'll mix it so that it'll actually be mixed with a beer later on. And so they can use it double. Okay, so if we're trying to determine the empirical formula, if we're trying to determine the molecular formula, we need the empirical formula. Once we determine the empirical formula, it's pretty simple to determine the molecular formula if they give us a little bit of information about the molecule itself. A compound has an empirical formula of CH2O. The empirical formula mass is 30 AMU. The molecular mass is 180 AMU. You need to determine the molecular formula. So in this case, they gave us the mass of the molecule. So then all we need to do is divide by the empirical formula, and then that'll give us the number that we multiply our empirical formula. Okay. So molecular mass divided by that's going to equal our factor. So in this case, we have 180 divided by 30, 6. Okay, so then we multiply our empirical formula by 6. C6, 12.
Okay.
Yeah,
So from the other example, we were kind of working backwards, and then this one we're kind of moving forward,
that's right.
trying to find the highest term.
Yeah.
Oh, okay.
Or in the case of the other examples, you're determining just the empirical formula. Here, they're giving you a little bit of information about the mass itself. Does that make sense?
When you wrote factor, it made a lot of sense, honestly.
Yes. That's right. Yeah, so you're multiplying each of them by 6. Does that make sense?
Yeah.
Questions? Questions? $1,000,000?
You make a harder example.
Let me give you a harder example.
Yeah,
Sure.
because I know there's gonna be harder ones.
Of course.
Let me pull one up for you.
Yeah.
If you convert this to this and then divide, you have to convert it first.
A second, let me find something.
This seems too simple.
It is what it is. There's not much to it.
You say that now, but there's only harder examples. So then we go to our homework and it's like, oh, convert this.
Well, if you're gonna ask, we ask it. Don't talk about yourselves. I have really good ears. My ears are burning. Man, they're on fire.
I wasn't aware we had homework due tomorrow. I've been studying for the test.
Every week you guys have homework. So you're asking me if I can give you guys a little bit of an extension. Since you guys, your exam is due on Wednesday,
Yeah,
and you guys probably haven't even touched this stuff other than what we do in class.
yeah.
You
Wait,
know,
send the test.
they can't extend the test. We've delayed that one long enough, so I guess I can extend the homework for you this time.
Push.
Thank you.
Just push.
But you gotta ask, otherwise you never know.
Oh, here it goes. Freaking out.
Okay, so I'm publishing it right now. And I convert it. It'll be in class. It'll say empirical formula.
Oh, yeah.
I'll open it up. I'll open it up first, like question. So then that way you guys. Rough time.
Look.
So is this hard enough for you?
Yeah, this is what I'm expecting on the homework.
Okay, good.
Not, not here's everything you need and just convert it.
Say this is a medium.
Yeah.
They'll get a take home test. They'll get a hard.
You want to take home test?
I want a what?
A take home test exam?
A take-home test? Sure. Is that the answer on it?
Yeah.
No.
Then I don't want
Are you
it.
gonna accidentally staple on the answer sheet?
No, I don't make the answer keys till after the exam is over. Just for that reason. Yeah. Oh, and some of the games that you guys.
Oh, really?
Columbia finally came in.
Oh, was it the orders that you guys postponed and that?
I called, I told them to cancel. They never canceled. They sent the dating.
Did you already pick up the chemicals back then, or?
They're in there. I just need to label them. Do you mind labeling them? I need to put them in our database. You get some access to the database. And you have to sign to give her access. You want to show her how to do it, and then we'll give her access.
We're both there.
Remember, initials.
Yes.
Hello, with gloves, because.
You had to ask for a hard one.
Hey,
You gotta
honestly,
be realistic. They're not gonna give us that
yeah,
easy.
we need this one honestly.
Yeah. It's not, oh, here's 60. Here's 10. It's like, no, they're gonna give us this.
Yeah.
But we walk through this, not gonna.
You brought this. Ready?
Yes, please.
Okay.
I don't even know where to start.
Yeah. We didn't give you a chance.
Oh, no.
Yeah, go for it.
4 minutes before I give up.
Well,
I already gave up.
We'll just work through it together.
Yeah, I'm with that.
No, I want to school. So everybody has this on their, okay. So I'm gonna do this.
I can see.
I can't see anymore.
Oh, no, it's just saying, or. Yeah. Do you use it?
Yeah.
That's my crack on what you want.
I want to hope
What was
so.
that?
Because I couldn't remember what you like.
Alright.
Because I had like three. No, I have four.
And then you just said three for me,
Oh, I have three.
This is what we're gonna get. That's why I asked for a harder
I'm
example.
gonna be basis with the easy question.
And I'm like, huh? I'm like, why is this just too easy to be true? That's why I left those. Okay, get harder.
I mean, you could. Oh, you might, I'm gonna forget that one. Yeah, that's over. See, no, see. I remember I used to do that before. Yeah, it sounds good. It sounds like really good.
Okay. So it produces a combustion reaction is going to produce carbon dioxide and water. So we have 41.33 grams of carbon dioxide. And then we have 2.728 grams of water. Okay, so these are going to be the only sources of carbon and hydrogen that we have. We know that the compound that we're working with has carbon hydrogen, and oxygen. We don't know what values they are, we just know that they have them. Okay? So we also know that we have 10 grams of sample that we used of our unknown. So how can I determine how many moles of carbon I have in this compound?
Molar mass.
Okay, of what?
Both carbon and oxygen.
Almost there. So we're gonna start off with this value. You're telling me I'm starting off with this, right? At 21.33 grams of carbon dioxide. I want to get to moles of carbon. But right now, I have carbon dioxide. So how am I gonna go from carbon dioxide? Mass of carbon dioxide. So the mass of carbon dioxide is
Oh, just this one.
carbon dioxide.
Oh, you mean both? Oh. Alright, I thought it was incorrect.
44.011.
But go with that left. It got me right at the last time. I messed up. One mole of carbon dioxide.
Oh,
Okay, so that gives me the moles of carbon dioxide. Do I want moles of carbon dioxide?
no, it's a carbon.
I want moles of carbon.
then
So
it's,
how do I get from moles of carbon?
It's a 1 mole is equivalent to the molar mass of carbon.
So 1 mole of carbon dioxide
Or carbon. Yeah, carbon dioxide and then more of carbon.
it's gotta be 1 mole of carbon. Okay. I do this.
I feel like I'm eating.
This is on.
Oh, yeah, we're using this off of the slide.
Okay.
I was gonna see if you purchased it.
I did.
Hard time. Okay, so what do we got?
4.846
What,
moles of carbon.
4, 4, 6.
Run 6 to 7 or no 6 to the 5 next to it?
I did it because the number next to 5 is 1. It's like.
5. Yeah, I think we keep it. She the way she explained it was a 0.484651, so it's a 51 after.
Oh, 5, 1.
Yeah, after
Okay, what, 4, 8,
46 51.
5, 1. So she rounded it up, right?
Just keep it the same.
Okay, let me make sure you're telling me. It's 5, 1?
Yeah.
Okay, so there's a number after this 5, so 4, 6 fixed there. So then, would I round it or would I?
You would round it.
You can, right? But I didn't.
You should, 4, 6 fixed. Be correct.
But
You round it up.
I thought you said that if it's a 5, you can.
Thanks. No, I said if it's a 5 exactly, right?
5 and up.
Oh,
If it's-
after.
Yes,
Oh,
so if
okay.
it's 5 and up, you round up.
So then,
If it's 5 exactly, you go up. It's not
So-
that you can. That, yes.
So if it's
Okay.
50 then it would
If
say.
it's
So we
5-0,
round up
if
to
it was
7.
5-0, then let's leave this alone. You do
Oh.
that 6, right? And then if it's greater than 5, so this is greater than 5. then we're gonna round it up, right? So we're gonna round it up to 7. All right.
It gets tricky sometimes on the rounding, honestly.
Yeah, that 5 is that 1. And then everybody, because we're so used to it, like I told you,
Yeah.
we've gone through life. Everybody says that if it's 5 or greater, right? 5 and greater. that's wrong. It's, if it's exactly 5, right?
Yeah.
If it's exactly 5, then it's gonna stay not rounded. If it's greater than 5, a little bit more, it's like 0.0002, that's a little bit more, then round up. I know, could you imagine trying to explain that to a second grade?
Nah.
That is so confusing, honestly.
I haven't tried, Actually, 3rd grade, now, not a second grade. Yes, my girlfriend's son is able to balance chemical equations already. We're working on this part. It's got dimensional analysis a little bit. And she's upset about it because she don't get it. And so he's coming over to try to help her with her.
You want them to make the million for you, huh?
Exactly.
I like it.
Okay, so we do the same thing with water, right? So now we're looking for hydrogen. So how would I find, starting with water, grams of water, how would I get it to moles of hydrogen?
The molar mass of water first.
What was that?
Molar mass of water first.
What is the molar mass of water?
Calculate.
18.060. 050.
Yeah, 0.50.
Guys are being exact. Okay.
We look for hydrogen or water?
We're looking for hydrogen.
For hydrogen. So then we look for how many hydrogen we have in the molar mass of the water.
And the molar mass of water.
Yeah, so one water molecule or one water mole is equivalent to 2 hydrogen moles.
So we're looking at moles, not molar mass.
Uh,
Okay. Molar mass means that you have mass present. How many sig figs? 4.
Point 30.
Okay, so we have our carbon and we have our hydrogen, right? And so those are moles of carbon and hydrogen. So we know that this compound also has oxygen. So if we're looking at the compound alone, right? We know it has oxygen. Now we know with the combustion reaction, combustion means that it's taking oxygen from the atmosphere as well to do the combustion. So we got to be careful about how we get that oxygen. So we can only use the value of our unknown, the mass of our unknown, to figure out our oxygen. Does that make sense? Okay, because if we try to use the oxygen for both cases, we would have too much oxygen because that would also be the oxygen from the atmosphere. Okay, yes. But it requires. Yeah. Okay.
That's it. That's
So-
Dr. Is that why, because even though we have 10 grams of the unknown, it's still between 250 and 300 because it's using more oxygen?
No, that isn't the reason why. They're just telling us that the molecular mass is. So this is the range. So typically, that's what happens with the program. The program recognizes what the compound is based upon its composition and how it bonds. And so it'll give you a range of things, and it goes through these ranges and calculates, okay, so the probability is that it's this compound because it falls within this range. So we need to figure out the grams of carbon. So we're going to use this to figure out the grams of carbon. I'm going to move back up here. Do this. So how would I figure out the gram of carbon using 4.847 moles?
You multiply it by 1 whole mole,
I multiply by what?
1 mole of carbon.
I would multiply, it, but I already have those. But I don't have that.
So 1 mole of carbon down and then 12.011 grams.
That's gonna give us.
Two,
Seven. On the same page that I have.
4,
Four, so then it should be five.
5.822.
Okay, and we do the same thing for the hydrogen. 0.3. Or you guys want to be more exact? Is it 1.008? Is that right?
We're good with 1. We're good with 1.
Be exact. You guys want to be exact?
Cool, we just
You guys get. Okay, so now we know water conservation says what we put in, we've got to get out, right? So this is the carbon that we put in. This is the hydrogen that we put in. So we can figure out how much oxygen that we're putting in by using that mass, right? Because they have to equal up. So if I go 10.0 grams minus 5.82 grams minus 0.3053 grams. That's the my oxygen. So looking at yes, that's the point after this. So this is the point. So you guys do that, the subtraction, the value, then you figure out the numbers it takes. You guys agree? Report back. You don't agree? What do you think?
Three?
What was that?
Shouldn't it be three? It's like this?
Nope. Because when we do addition and subtraction,
Oh.
we go to the point of significance, so that would be 1 point after that's this one. So math, we have to look at just after this, and either round up or move on. 3.8, 7. You guys remember that?
Yes.
Okay. So, and then now that we have the mass of oxygen, we need to change that to what? That's mass of oxygen. What are we gonna do? Change it to moles. Okay, so we have 9 grams of oxygen divided by 16 15.999. So we have 0.4847. We have 0.3029, and we have 0.24. What is the smaller number? Okay, so then we're going to divide everything by what? And then four. And 0.24. Oh, right here.
Yeah.
Scared to touch it because just got it to work. I'll just move it over. Please, John. This one. Oh, shit. That's it for 2.1.
I think it's 0.2. It's yeah. It's a 9.5 after that. No, a 2 right there. I took 0.
I know, but there's two same things, right?
Oh, I see.
Okay, so then our answer is going to be this one's kind of tricky.
I see, I wrote 5. Where it says 0.
Right.
I wrote 5. That's like
I know.
yeah, exactly.
With 3 on the hydrogen. That's fucking crazy.
This is just.
Okay. So then what do we do now? Change it to whole numbers. How do I change the whole numbers? We can multiply by 3, which technically would be incorrect, right?
4.
Right? We would multiply by 4, right? Yeah, so this is the one time that sig figs did us wrong, right? Because then that would have us split middle multiplied by 3. Because it should be this number here, this should be 1.3, right?
Oh,
If you do sig figs, right? But if we don't do sig figs, it's 1.26, which is close to 1.25. So we multiply it by 4.
So we would or wouldn't use the 6 big.
So, no, actually, sig figs was wrong. I would have given you a question that was so this close that, that value because they're not setting up or a mistake. Because technically you should use the sig figs. So, sig figs. If you were by using sig figs, it would still be wrong. But then it's the program, right? So if we multiply it by 4,
I got for that one, great.
C
I think
eight
I got
H
five.
5. Oh,
yeah, so you get 5.
Hardly I got 4 right, so I think. Four.
Okay, so then C, put it over here.
I don't like this. It confuses me because it's 1.262. How do you get 1.25? How can you go down?
You can't go down technically, but it's closest to 5. It's not closest to 0.3. So it was like 0.333, right? If you look at the number, right? So we have 1.25, right? Yeah, 1.333. So that is, this one we multiply by 3. This one we multiply by 4, right? So our number is 1.262, right? So then that would be 1.26. Which one is it closer to? So does that make sense?
Yes.
So, but again, I personally wouldn't have given you a problem that is so tight because technically if you're using sig figs, you should have gotten 1 point and they would have given you the wrong answer.
Should we be looking for this exception then during these problems?
Not for your exam, because I made sure that there were. Yeah, the person who did this was a dickhead who made that problem. No, I'm like, that is serious, because, and then I'm gonna, actually, I'm gonna write about that too. Like, they're gonna use the same figs, they would get the wrong answer. Okay, so now that we have our empirical formula, how am I going to use it to determine my molecular formula or the range of my molecular formula? Okay, so how would I do that? Okay, so 8 times 12. 5 times 8, and 4 times 15.9. I know, we're using every little square section of the board. Okay. What do you guys get?
I got 96.088 on the first one. 5.04 on the second. And on the third, I got 63.996.
Okay, we got these together.
So we got 165.124.
And it says that that determine the molar mass of the compound if it is between 250.0 and 350.0. Back between 250.0?
No.
Okay, let's give multiply it by so that it's between
2. That's it.
by 2. Okay, so we multiply this by 2.
It's 330.248.
Anybody entered in there?
This question would have.
Pulled it off the action, but we just did it all together.
I usually give you
Again,
one
the
question.
that was the answer.
There's gonna be like 4 now.
Over. That's why. I think they like that.
Because it has to be between 250 grams. Per mole.
You gotta go back. Oh.
330, 160 grams per mole over the empirical formula. I believe. Not done here, right? Okay.
Yeah.
Isn't this supposed to be like over the empirical formula? Is it-
The molecular formula.
I can
Yeah.
get my.
So it's, you guys got 330.248. Oh, you're talking about for the chapter?
Yeah.
Oh, no, we're not done with the chapter.
No. I was talking about. So we're doing what the derivation of molecular formula, right?
What was that?
Derivation. So.
No, you just did that.
This one, right?
So we just did that. We already did that. And so we're talking about molarity. That's where we're at. We're going to talk about molarity.
Okay, but this is the answer.
That's the answer. Yes. Because it's between those two values, right? Isn't it between those two values?
So then, what's this about?
No, so this is one way of getting it. If you're given, if they give you the mass, right?
Perfect world scenario.
Exactly, perfect world scenario, but this wasn't a perfect world scenario. They're saying that it falls between these two, right? If you read the question, it says the molar mass of the compound is between 250 and 350 grams per mole. Okay, so if it's between 250 and 350, right? This is our value. This is our empirical formula. What can we multiply it by so that it would fall within between 250 and 350? Well, if it's 1, that would be too small, right? That's less than that.
So
Correct?
the answer for this specific formula would be 2.
That's right. Does that make sense?
Not in the slightest.
Okay, so
So
let,
we did all that
let's
just to get 2.
yes, that's right. So you figured it out that it's 2. You're multiplying it by 2. So your empirical formula is C8H5O4. Your molecular formula is C16H10O8. So that would be the molecular formula.
We multiplied everything by 2.
Yes,
We
that's
actually
right.
have now.
To get in between the range.
Yes. Yeah, because if you multiply it by 3, it will be greater than 5, right? Because if we multiply it and then, so 2 is the only logical answer. Does that make sense?
It makes sense
It
now.
makes sense. It's still, this is a, it's a good question, but it's also an asshole question. The second part of it being arranged, that's typical because that's what happens. That's what the computer So the computer typically does that for us. So we don't have to do it when we do analysis. So if we do the analysis of a compound, you plug it in, you inject it in, it'll actually do that part for you, right? And so it gives you the actual compound at the end of the day. But you need to understand that if you don't have that nice piece of equipment, which we probably won't have, right? Then this is how you'd go about doing it. Does that make sense?
So when it's asking for that in the active learning, we have to put in 3.3 or 330.1.
That's what you need to put in.
Okay.
Is that what you put in? Well, force it fixed.
Instead of the 2 formula units per molecule.
Yeah, so this one here is different. This is a different circumstances. So they're giving you exactly, this is how much it weighs exactly, right? And then this is how much your empirical formula weighs. And so in that case, you're just dividing it, right? Don't overthink it, you'll be okay.
This is the grand example, putting everything together.
That's right. Yes, you asked for a hard one. I gave you a hard one.
I'm trying to
but-
understand
Yeah.
it so that I don't get confused when I'm doing the home.
Yeah.
Yeah, this one actually does help a lot.
Okay, so yeah, but it's what you guys, typically, if you look at the lecture, how the lecture works is we give you pieces, right?
Yes.
And then we give you all of the pieces to put the puzzle together. And then on the homework, that's when you're putting the puzzle together, right? So you're using everything that you learned to put the puzzle together. But typically, this is what you guys do because you know the pieces, right? And you just think about the pieces, you don't think about the puzzle.
Yes.
And that's what we need to get you guys to do. Everything is about thinking about the puzzle because you're always going to have the pieces. You have the foundation. You have the foundation to sit there and solve the world's problem right now. But we can't put those pieces together, right? And that's what you guys need to work on, right? And so what they do, they have the study group on Fridays, right? Is that my understanding, right? And so, and they said we spent an hour working on one problem, right? Or 45 minutes working on one problem, right? But I bet you that problem was you have the pieces, you just weren't putting the pieces all together. And that's why it took you 45 minutes. And then finally, when you guys, it clicked, you're like, you could probably figure out that problem now in like 20, right? Or 15, you know? 10 minutes, yeah. So, but the key is that what I want you guys to get out of it, anybody can do the groundwork, right?
Yes.
I don't watch those people, right? Shit, I can, I pay attention to do that shit, right? I want people who can think because you need to be able to think to solve problems, right? Those are the people who make the money. It's the ones that think about things, right? The ones that, that can sit there and just follow instructions, they get paid cheap, right? And so you guys are the thinkers. That's what you guys are here for. You're thinking, to think, right? Does that make sense?
You're still gonna think it the same.
Okay. Everybody got this down?
Yes.
Sometimes I write and I'm like, what the hell wrote this?
I see all this and I'm thinking that's my problem.
It's so good. This man doesn't have any questions. Yeah.
I try to completely make it.
You already knew.
Is she ill? What's going on?
Yeah, we're on the jacket.
Why don't you guys chat? Okay, girl. He's been talking always about you. No, don't say that.
Oh, that's it.
Yeah, but we can ask, say, Dr. Henry wanted to know where you're at. Get in the habit of looking out for each other. These are your road dogs.
You said something about quiz and you were saying.
Oh,
No, it's because you didn't say anything about quiz.
I said, do you guys want a quiz? I said, do you guys want a quiz? I said, I'm not gonna give you a quiz today because you guys have a test.
Oh, that's fair, that's fair.
Okay, how are you guys doing? Everybody's doing well?
Feel better now,
A lot better, right?
honestly.
Yeah, good. Okay, so
I need
let's
an
move
example
forward.
to get through this.
We gotta finish this chapter because we're behind. We are so behind. Did I give you guys the 10 handout for labs?
Yeah.
Yes.
we skip lab 8?
You guys did skip lab 8. You're gonna be doing, technically, you're gonna be doing lab 8 today, but I'm gonna give you an option. We'll talk about that here in a minute first. But first, we need to finish this chapter, because God damn it, this chapter is killing me. And I'm blaming Victor. It's always Victor's fault.
Oh, we need 2 copies of that.
It's gonna cost
It's
you
not,
$700.
it's never gonna look this nice. Maybe for like one question.
Until you get paid on Friday. Eight. Okay, if I have it, I'll get a copy. Yes, after. Okay, so we want to talk about molarity. Okay, now molarity is concentration. We're talking about concentration. How many of you guys make Kool-Aid? Everybody makes Kool-Aid? Anybody not make Kool-Aid? Rich Rose, that's what it is. Y'all got money, that's what it is. Okay, I still make Kool-Aid. I got my Kool-Aid in the cabinet.
Yeah.
Okay, so when we think about Kool-Aid, we can think of it in a couple ways. Have you guys seen the squirt bottles, the Kool-Aid squirt bottles now?
Yes.
Yeah.
You haven't seen- Okay, you need to go shopping. That's what you need. We obviously, you must have a man in your life that takes care of all of that stuff. She's the brain and she's the breadwinner. And he's in the kitchen. He has to take care of it, right? Exactly. Okay. So now there are these little things of Kool-Aid now that are squeeze bottles. So that's an example of a concentrated solution, right? It's concentrated and you have to dilute it so that we can actually drink it. Otherwise, it tastes pretty nasty, right? If you guys, I don't know what I put everything.
I know by accident.
I'll be honest, by accident.
It's bitter as
Sure,
hell,
right?
honestly.
It is so bitter, right? Because it's so concentrated, right? It is such a concentrated solution that it tastes horrible, right? So we tried to make Jello shots with it, and stuff like that. So you had to experiment how much you put in there, right? So when we talk about molarity, molarity is basically moles, again, quantity over liters. Now, but it's moles of solute. Remember when we talked about the solute?
Yeah.
Okay, what is a solute?
I don't know, but yeah, it's a solution. Talked about it.
When we talk about it, if you don't remember it, that's no good, right? You're supposed to remember that stuff. He's like, fuck it, I just dumped it all out loud. It was like, that was last month. I'm not remembering a damn thing. Right? So, hey, that's all good if you don't remember. Somebody help me out. What is a solute? Victor, since you took us off this track, you gotta bring us back. What is a solute?
I'm the same as him.
Oh, so you're exact same as him. Solute, anybody? Say it. Come on.
It's like something that you have to dissolve it for something like into the word.
That's right.
It's a solid.
Solute, that's right. So it is, she says, for example, Kool-Aid. The Kool-Aid packet is the solute, right? It's something that we have to dissolve in something, right? Yes.
What's the difference between a solute and a solid?
Solute,
Yeah.
solvent. Solvent is the one that is most abundant. The water is the solvent, right? So solute is usually the least abundant, okay? Or another way of looking at it is the solute is the thing that needs to be dissolved. The solvent is the thing that's doing the dissolving. Yes,
Is
sir.
it kind of the same with like solid fiber, is the soluble wall solvent, polymer is not?
Sort of, yeah, sort of. It is along those lines, but the solvent is what's doing it, right? Okay. Okay, so when we think about a solution is a combination of the solute and the solvent. Okay, so when we talk about molarity, so when we talk about molarity, Molarity is going to be equal to moles of solute over liters of solution. Okay, that's your molarity. Okay. Now you guys already know how to calculate moles, right? And so, and liters of solution is typically given to you. It's real simple, but it's a good way of how we move liquids around or how we move chemicals around, because we'll put them in solutions to make it easier for us to sit there and do chemistry rather than having to weigh everything all the time, right? You can just sit there, oh, I just need 5 mils of this, or I need a liter of this and 5 liters of this to do the scratch, right? Real simple compared to, okay, let's go weigh it, you know. So, make sense?
Yeah.
Okay. So let's do a quickie problem on the side. This will kind of help you understand. So if I have 5 moles of NaCl, and I'm going to bring it up in 500 milliliters of solution. Now, typically the way I would do this is I weigh my sodium chloride, get it so that I have my 5 moles. I'll pour that into a volumetric flask. Do you guys know what a volumetric flask is? Let me show you what a volumetric flask looks like, because you do need to know your glassware, right? Yeah. It's dirty. That is a volumetric flask.
What's the classic flask named again?
Erlenmeyer,
Erlenmeyer.
yes. Now, a volumetric flask, a volumetric flask is perfect. You see that line around the neck?
Yeah.
Okay, that is the perfect volume for, in this case would be, I'm assuming it's about a liter, maybe 500 mils. Usually says on the bottom. What does it say? Liter?
1,000 mils.
Which is a liter, right?
How accurate?
It is accurate. I mean, it is like 0.01% off. It is accurate. It is on point, right? And so you're usually, that's why chemists love using them. Like real chemists, real old school chemists, I hate using them. I mean, real chemists, real. See, that's why, remember I told you you have technicians and stuff? That's what my technician would do. I just do all the calculations and do all the thinking. I'd have them do that because then they measure it down to that perfect line. I am too impatient. You know, drop. I get, okay, I'm not patient enough to do it. So I would always have a technician working with me. You take care of that. I'll do the thinking. You do the work, right? Again, I look pretty. You know, but I would always give them credit. You know. Okay, so the thing is that when you're making a solution, you want to be exact, right? You got to keep passing around so everybody's.
Yes, I'll get it.
You notice how you just take it from the I'm taking this home, put it in my bag, right? So now you want it to be exact. The reason why you want it to be exact is because you want to make sure your concentrations are correct. Because if your concentrations are off, you can cause everything to go wrong. Nothing will work. We had some experiments. I had a new technician, and they couldn't understand. I'll get to you in a minute. Hold that question. They couldn't understand that they had to be exact. They had to hit that line. Brand new technician, right? And I'm like explaining to them. I said, okay, so you want to make sure that you're exact. Right? Oh, yeah, I got it. They would fill it all the way up to the top, right? You see, very top there, which means that you're not at the concentration that you're thinking. It's much more diluted than what it should be. So we started doing an experiment, and I'm like, you know, I have my controls going off, testing out. Why the fuck are my controls off? Everything's off. And I'm like, man, it's taking me, instead of the experiment took about 2 hours to run, it's actually taking me 4 hours to run these experiments because the concentrations were off. And there was another reaction that was happening. It was a time reaction. Yeah, one reaction going on, yeah, another reaction that follows. And it's a sequence of reactions that have to happen to synthesize what we're trying to make. God damn it. And we kept getting not enough product. And we we get this byproduct, which we really didn't want at all, right? And so I'm like, okay, so this is not right. This is not right. So I'm like, okay, let's try it again, you know? Had all the instruments, you know, paid to get it recalibrated. Everything was perfect. Technician, I said, okay, I need you to make some more solution. All right, not paying attention. I come back and I see it filled up to the very top. And I'm like, you know that this line is the one liter line, right? I said, that's all it's supposed to be up to. Oh, I didn't know that. And I'm like, okay, so that explains everything, right? Now, but we had wasted a month's time sitting there trying to do these experiments over and over and over again. And I'm like, and then also the money that we spent, right? So the reagents were on the average, they're paying about $56,000 per, I think it's like 5 grams of this product, right? I mean, it was insane. My company was not pleased at all, right? Because then, I mean, we did it, I'm gonna say about 5 times, right?
How many grams is just?
Oh, Jesus Christ. We went through quite a bit, right? And so, yeah, they were not happy about it at all, right? Once we got it to work, they recouped their money, they were fine. But in that time period, I was like, fuck, you know? And then, but whose responsibility is it? I'm the thinker, right? At the end of the day, I have to take responsibility because I didn't take the time to train them. I assumed that they knew. They're from Stanford, they should have known, right? This also tells you, sometimes the education that you get may not be as good as you think it is, just because it has that stamp of approval from Stanford or Harvard or wherever, right? Sometimes you get the best damn education at West Hills Community College and you learn the things that you should have known, right? And so, yeah, it was a valuable lesson for me, you know, also not to sit there and rely on the pedigree, right? Because pedigree doesn't mean shit. At the end of the day, it's about the work that's being done that day, right? Okay, so when we do this, we want to make sure that it goes right up to that volume, right? You got to be exact, you got to be patient. And that is the hardest thing to do, especially for people like me. I am, like I said, I'm a thinker. I think a lot, constantly thinking about things, thinking about the problem, thinking about this, thinking about that. So I love technicians, right? I make sure that they get what they deserve. They get their pay that they deserve. I try to fight for them every chance I get. I give them credit when I can give them credit. You take care of your technicians because your technician will take care of you, right? And that's what you should always do as an employer. Always take care of the people below you because they will take care of you. So anyway, if we're doing this, what would be the concentration or the molarity of salt that we have?
I know you said 500 milliliters, you wrote 5,000 on the.
1
Oh,
mole
sorry, I
per
meant to say
1,000.
500. Yeah, I meant to say 500.
Oh, okay.
1 mole per liter.
Okay, so it will be or we would say 1 molarity. So typically when we write the molarity, there's 2 ways of writing it. Sometimes they just put the M. You'll see them write it with the M, but really it should be the M with the underline underneath to let us know that it's molar, right? Or molarity. So we'll call it molar concentration. Is the other name. Then of course we put NaCl. So 1 molar NaCl. Let us know that that is the solute. And a lot of times that little bit of things is the one that's important. That's the one that's doing the work. That's the one that's going to be reacting. Okay. Okay, questions? Concerns? Dash?
And to write it out, we just use a conversion factor.
What do you mean with conversion? Oh yeah, you're going to convert it to liters. It always has to be in liters, right? So that bottom, that's why we said moles per liter, right? Good question. I think it was actually a very good question. Yes.
What if it's not a full liter? You just say like half.
So if it's half a liter, then you divide it by 0.5, right? Yeah. So then you divide it by 0.5, you just change your convert it to liters. But you always want to convert it to liters. So molarity, it will always be in liters. Moles per liter. Okay, now sometimes we get tricky. So for instance, another example. So now, actually, I'll say, because I need to introduce a little more stuff to you first. Okay. So how can I use this? If you guys are going into biology or the life sciences, we use it like crazy in the life sciences, but we prefer not using moles. They don't like using molarity. They use what they call 10x. 10x would be a stock solution, 1x will be a working solution. X represents whatever concentration it's supposed to be, so they just call it X. So they'll have a technician make that solution, and that would be 10x. 10x would be 10 times that stock solution, or 10 times the working solution, sorry. 10 times the working solution. And 1x would be the working solution. So often what we'll do is we'll use these to make concentrated solutions that we use later on, kind of like that Kool-Aid, right? And so then we set it up and we dilute it down to a 1x working solution. That's what we use for the experiment. Because it's a lot easier to store 10x than it is to store a whole bunch of 1x. Does that make sense?
Yeah.
And then sometimes what happens is that if it's too dilute, that solute that's in it degrades. You know, by having a lot of it around, it kind of keeps it a little more stable as well. So those are two things that happen. So the way that we use this a lot of times is we use it to work as a starting solution. And then we want to do it down to a lower concentrated solution. Okay. So, but first you need to understand this, right? Number of moles. N represents the number of moles. And in the case of molarity, it is molarity times liters. Okay. So if I'm thinking about diluting something, say again, Kool-Aid, right? If I have the number of moles of Kool-Aid divided by the concentration, that's stock concentration, and I want to make a solution that is more dilute, the number of moles can be exactly the same, right? But we're just putting it in a larger volume. Does that make sense? So then I can sit there and say that, okay. Now we're going to make this a little more generic because we can use different means of concentration. We can use percent mass, we can use percent volume, we can use percent mass volume, we can use any type of concentration. We can use 10x, we can use 1x, we can use any of those types of different concentration. And we're going to have this equation C1 V1 equals C2 V2, where C1 equals the concentration of stock C2 equals concentration of diluted solution. V1 equals volume of stock solution. And V2 volume of So this equation and this equation are exactly the same thing, only the M represents molarity, L represents liters. Okay, so exact same concept, same equation, but represent it so that we can use it for everything.
So in terms of the C, would you put moles there? Or would you?
Yeah, it would be molarity.
Oh,
Right, you put the molarity because it's based upon the molarity.
and that's the concentration.
That's right. Okay. Okay, so let's use this with our problem here. Let's assume that this is our stock solution. And let's say we're going to make a saline solution. Do you guys know what a saline solution is? Saline solution? Saline solution is just a salt solution. Sodium chloride is diluted. So typically we use it in biology, stuff like that, to be equivalent to the amount of salt that you have in blood. Yes. Yes, and also in your eye drops and stuff like that for your contact lenses and stuff like that. That's a saline solution. So typically, I'm taking a real big guess here. Typically, it's like 0.009% with percent weight salt in the saline solution. Okay, so we're going to put it in moles here. Okay, so instead of saying 0.9% weight, we're going to say moles. Right, so we're going to go 0.00. Zero. And we're going to make 30 liters. Okay, so we're going to make 30 liters of a 0.025 molar salt concentration, starting with our stock solution of 1 molar sodium chloride. How much
Are we looking for V1?
That's right.
We just plug them in, all the other factors, and it's all for V1.
That's right.
And then the 0.00025 making 30, that would be on the right side,
Okay.
on the 2.
So okay. 0.0005. Solve for V1. So C1 is
1.
2 is
30 liters.
V1 equals what do you guys think?
Not 0.0075. be in meters, right?
It's okay. So, and that's one of the reasons why we want to use concentration, right? We want to use molarity because it's this simple equation to sit there and dilute everything to what we need it to, right? You don't have to sit there and weigh everything. And, like once you have that stock made, you're good to go. Just first making that stock. Yeah.
Oh, yeah, so I kind of got stuck on math, right? So they multiply 0.0025 m times 30 divided by 1. All right, that's what I wanted to ask.
Okay, you had a question earlier.
Oh, no, those were you mentioned. But you had written 5,000.
Okay. Okay. Questions, concerns, Gash, Kool-Aid? Okay, we're working through it pretty fast. We're almost there. Home stretch, okay? I guess I should probably. Okay, so we've already talked about solvent and solute. We've talked about solution. Now, in chemistry, we use a lot of aqueous solutions, basically meaning that we dissolve everything in water. Because water is a great solvent. Occasionally, we have to use other types of solvents. One of them is methylene chloride. That's one of the more commonly used. And then also DMSO. It's dimethyl sulfur oxide. So we'll talk about that a little bit. Okay, we know what concentrated means. Concentrated is when there's a whole bunch of stuff in there, relatively toxic. And dilute basically means is when it's very low concentration. Okay. We've already talked about how to calculate molarity, right? So this will be an example, but I already gave you guys a better example. So when we talk about dilute solutions, we see dilute solutions all the time. Our bleach is diluted. Our vinegar, do you guys vinegar?
Yeah.
Vinegar is acetic acid, basically diluted to about 5% acetic acid, and then the rest of it, 95% of it's water, right? So here's an example of something that's concentrated. You see the concentrated, the second part is diluted, so that's a copper nitrate. This is how we would go about making a solution. I already talked about that. We weigh it, we put the powder in, and we bring it up to volume. Now that's going to be very important, and you need to be able to explain that or recognize how to explain that on the test, right? Because that will definitely be on every test. That is the one thing that every one of my students will learn, because it drives me crazy when I have them in here and they make a solution and they fuck it up that way, because then they don't bring it to volume, right? Because it has to be that concentration, has to be that solution.
So what do we need to properly explain again?
So to explain it in detail, see how we have the weighed product, we're going to put that into our volumetric class first, and we're going to bring it up to a liter, right? We don't want to sit there and add a liter of water and then add it to it. And you don't know how many times I will tell the student, yes, sir.
Oh, I'll let you finish your story.
You don't know how many times I will tell a student that. They'll be looking me in the face after I just told them to do that, and they will do it themselves. They can ask you, because I always get on them about that, about how to make a solution properly. And if you make it wrong, we're gonna make it again. I'll keep you here all night. One night we were here till we get out at 9, we didn't leave till almost 11, because I had to make the solutions all over again. So, and believe me, I want to go home, but it's important.
Yeah, so the question is, so it has to be underneath or on that line?
Good question. So this is that whole concept of measurements. So that meniscus. So the meniscus has to be right on the line. So water always forms a meniscus like this. If we're using something like mercury, right? Mercury forms a meniscus like this. Most solutions, most solvents that we use, they will form a meniscus like this. That meniscus has to be right on the line, right? So here's the line here. This is the line. So the meniscus has to be right on that line. That is the perfect solution. Okay. So it's the same thing when you have the graduated cylinder, right? So
I know it's
the cylinder always has to be on that line that you're trying to get to. If you want 5 milliliters, it has to be, the meniscus has to be at 5 milliliters. Okay. So if we take a look at this, let me show you. The meniscus is going to go like this. It's going to be right at that line. So it'll be right at the line. So it should be right at the line. With it like right there at that line. So take a look. It's hard to tell with like my marker's about that thick, but it should be right at the line.
And like you said, since it's a meniscus, the actual water, it'll appear to be a little bit above and
That's
then it'll drag down.
Yeah. So because it always, so the meniscus always forms like this, right? It's always like a curve, right?
Can you draw it
So
on
the
the
line
other
is here. Your meniscus should be right at that line. Right? Not above the line, right at the line. Does that make sense?
Yes, Dr. Henry.
Dr. Henry,
Yes.
excuse
Oh,
us.
you guys can't see. I'll draw it over here too. I'll be fair. So here's the line. And so your meniscus has to be right at the line. Okay. Right there. Exactly. Yeah. Okay. So you understand the math term. So that's how you
Yeah.
get for you. Okay. That's good to know.
People don't like to get semantic. Chemistry literally requires semantics.
Okay. So okay, so this was the outline that I was talking to you guys about. We've already done this, right? So the before and after. This is just changing it so that we can use it for any type of concentration. Here's another example. Okay. I'll let you guys figure that out on your own. Since you guys already have the answer, right? What do you guys want to talk about?
Let's talk about it.
Want to talk about it? Okay. So if we have 0.85 liters of a 5.00 molar solution of copper nitrate is diluted to a volume of 1.8 liters by the addition of water, what is the molarity of the diluted solution? Okay, so in this case, we want to solve for the concentration too. We're given, think about what's given to us. And the way I always do this, and I'm telling you, I always do it because, you know, sometimes you go on these tangents. I write down what each one of these are. I have my C1, my C2, my D1, my D2. Now, in this situation, I know, put it on the board too. So, steal my laptop and bring it over with me. We'll share this. You guys have the example on yours. Can you guys read the example on your slide?
Yeah.
Anytime that I do dilution problems, or I also do it with gases and everything, I put down what my givens are for each one. Right? So, in this case, so it says if 0.850 liters of a 5.00 molar solution of copper nitrate. Okay, so what is 0.850 liters? What is that?
This would be our V1.
So that's going to be our V1. Okay, and then what is 0.00 molar? Copper nitrate. Is that? It's C1. And then it says, is diluted to a volume of 1.80 liters.
That's our V2. It's all about looking for those key terms on.
Right? So it's really important for us to understand what the units are, right? So we need to know that L means liters, right? And so that we're talking about volume. So it goes back to that week that we learned about the different units. Okay, so we're looking for this. So we just solve for C1. So we solve for C1, C2. C2 is going to be equal to C1 V1 over V2. And then it's just plug and check. Plug it in and chug it. Or a diagram. Well, and then just very C2 is going to be equal to. Okay, questions? Agree? Disagrees? Okay. Good. Okay, so as I said, molarity is useful. Chemists love using molarity. Biologists, they use 10x. Sometimes they use percent mass. Sometimes they use, so it just depends. And so it depends on the industry that you're in, what they're going to use for concentration. So you need to be flexible, right? And you need to be familiar with all the different types of concentration. One of the other concentration is percent mass. So in the case of percent mass, is the mass over our solute or that component over the mass of our solution. Okay, so that would be percent mass. Okay, so often what I do is I'll give you a problem where I give you the percent mass and I want you to calculate the molarity, or I give you the percent molarity and and then I want you to calculate the percent mass. So, and I'll give you an example of that in a second. Okay. So often we look at things that we work with in kitchens or in households, they're often percent mass. So for instance, bleach. So bleach is sodium hypochlorite. So, I'm sorry, chloride. So bleach, concentrated bleach is 7.4% sodium hypochlorite. Okay. Now that is the concentrated version, right? So we'll often use that and we need to dilute it to sit there and use it in a laboratory or in our bathrooms, right? Or do you guys use bleach concentrated in the bathroom? The other thing that we use is called percent volume percent. So it's the volume of a solute over the volume of solution. So this is when our solution is typically, or sorry, our solute is a liquid, right? So it may be easier for us to sit there and use percent volume. So then again, we also multiply it by 100 since it's a percentage, right? Okay, sometimes we get creative and we use mixtures of it. So we have percent mass volume. So that would be the mass of our solute over the volume a solution, right? Because we're too lazy to sit there and weigh our solution, sit there and make it all the same. So we'll do something creative like this. And believe me, it is done in different ways in different labs. And so again, you have to be flexible and you need to make sure that you understand what you're talking about, right? So we often will sit there, you notice how they wrote it, it's mass over volume. So it'll be percent, 0.9% in the mass volume to let us know that we're talking about mass, or we'll say percent mass of whatever it is, so chloride, or percent volume of alcohol, right? Because we need to know how they're doing those terms because it's going to be different under different circumstances. Does that make sense?
Yeah, I think these are different calculations, different equations, if you don't know that.
That's right. And so this is that part about communicating in labs. To be successful, you have to communicate in labs. So here's examples where we're using the different ones, right? So in terms of sodium chloride concentration, physiological saline. So I was off by a couple of zeros there. So 0.9% mass volume, right? Which is quite different than molarity. But you should be able to sit there and go from mass volume to molarity. Easy calculation, right? Because it's the mass over the volume of solution. Mass of solute over the volume of solution. How would I do that if I was asked this question?
So the mass would be 0.9. The volume would be, does that be liters or?
It'd have to be in liters, but this mass volume is normally grams per milliliter.
Oh, okay. So over the 100?
Yeah, so we'd have to change that milliliters. If we were going to molarity, we'd have to change that milliliters to liters. And we'd also have to convert mass to moles. Right? So you could easily convert from one form to the other. Okay. So another one is parts per million and parts per billion. Often if you go into agricultural industries, if you go into poisons, toxicity, you often will be using ppms or and ppm, right? Parts per billion. So you need to be familiar with both of those. Parts per million is mass of the solute over mass of solution times 10 to the 6. Because the quantities that you're looking at are so tiny that we need to amplify them so we work in such small numbers. And that's the same thing with parts per billion. Right? And so often when we're talking about lead toxicity in the pipes in Michigan, right? Those would be in parts per billion, right? Or parts per million, actually. We were getting parts per million where they should have been in parts per billion. Okay, questions? Concerns?
And the parts per billion would be much lower on the concentration.
That's right. I said that in Michigan, I said in terms of determining toxicity of lead, so the numbers were in parts per million, where they should have been in parts per billion, right? In terms of the lead that was in water, right? So there were about, I think it was like 700 parts per million, right? Which is crazy when they should be in parts per billion concentrations, right? So you could imagine the toxicity those kids were getting by drinking the water from those pipes. Or what's happening in Mississippi, right? Currently, right? So they have issues with bacteria concentration. So there's a level of bacterial concentrations that's okay to be in the water, but they were getting. I mean, we're well above parts per million, right? We're sitting there. We're talking about 7,000, 8,000 parts per million. But typically, they use what they call colony forming units. So they'll pour that water on a plate. And how many colonies would go up on it. Well, the plate was a lawn, essentially, which means that you have a shitload of bacteria. And so, and then these communities, these low income communities are just accepting this because they don't know any better, right? And so they're getting sick, things are happening to them, their health is going bad, they don't know why, you know. Where a lot of the high-end communities have filters and things that are attached to their systems, so they don't feel the effects. So filters are built into their houses, things to that extent. So as good scientists, we want to be able to sit there and recognize it, and then also recognize what would be acceptable levels if you're working in industry such as this, right? And so you need to be able to convert from the different types of concentrations and maneuver yourself through it. So this is one of the things that I will always ask you. I'm sure you answer questions, we'll always end up having questions like this. Okay. So this is just an example. So in the case of water, trace elements of arsenic and stuff like that, we can have those levels, but they have to be very, very low, right? Because we know that arsenic is a poison for us. Right? It stops our glycolysis cycle, right? So high levels will actually kill us, right? Of arsenic.
It's crazy to think like one little fraction of and anything in our products, you know, they could go to the other side of things.
Exactly. And that's the thing, and that's what people don't realize. And as scientists, when scientists make mistakes, it causes bugging issues, right? So scientists, you can't make those mistakes, right? Doctors, nurses, you know, water technicians, right? You make a simple mistake, one calculation, right?
When you need
Fluoride, exactly. Yeah, so fluoride is added to water, right? High levels of fluoride is also a poison for us, right? So you need a small, very small level of fluoride that's added to water, right? It's basically used to kill bacteria in the water system, and it also helps our teeth, right? That's the reason why our teeth don't rot as much, or part of the reason why our teeth don't rot as much. Although our next generation, since we drink a lot of bottled water or distilled water or filtered water, we're filtering out a lot of that fluoride. Right? And as a result of that, if you notice, the cavity increase in terms of students and kids are a lot higher than, let's say, my generation. Right? So I see a lot more rotting teeth than I see before, because they're not putting the fluoride in the bottled waters within our water system. Right? But one, a technician that's allowing the addition of fluoride, he makes a miscalculation, and he puts it up a little too high, and then that just goes off the whole population, right? So very easily that can be done. And so it's really important that we have those checks and balances, right? So typically you have somebody else watching, they have to sign off on things and stuff like that, making sure that somebody don't get mad at my wife, so I'm gonna kill that whole damn neighborhood, right? So.
Yeah, a question back here.
Yes. Yes, it is. Any other questions? Okay, so let's take a break. And so here's your option, right? We could do the lab today. I have no problems. We have everything that you need to do it. That would be lab number 8, or we can go through and do some of the problems for the exam. Right? But that's up to you guys. I'm not gonna twist anybody's arm. We'll have a vote. Vote wins. Okay, those who want to do the practice exam, raise your hand. Those who want to do the lab, raise your hand. So I have one. So you lost, damn it. Sorry. I'll be mad at them later. Damn it, this is the reason why we have to do 2 labs one day, right? So, okay. Okay, so what we'll do, we'll take a 10-minute break, and then we'll come back and do practice. What was that? R7.
R7.
Oh, yeah. Don't worry about it. I'll give you guys some extensions on that.
Yeah.
Since I hate this plot too. Man.
Sometimes you see the board.
Yeah, this plot is
I was
just like,
looking, I was like, he's drawing something.
I'm forgetting to grab my other pair of glasses.
yeah, I'm trying to get better at remembering, and sometimes you just gotta throw something at me. Dr. Henry, damn it, just blow me one day. It would go into the rest of the indicators, but this is bias. So falls under bias. And this one goes. No, so this would go under phenols.
So with this, just put next to Dr.
Oh, no. This would go under.
No.
This one here would go under. And then that goes into.
Where all the other chemicals
Yeah.
that are saccharin.
Yeah.
Do we label that one?
Yes, you want to put, you always want to initial it, right? Date that it came in, right? So it came in today, so that's the day that we're recording it. Yeah. Day that we got it here,
Okay.
so.
Then,
The actual
no,
other one?
Okay.
And all these are going over polarity,
I
and
ask
equals N. Is that,
It's molarity times liters equals number of moles.
okay, all right, thank you.
Yeah, I also came back from my chat.
So
I finished the exam.
you've already finished the exam? How did you do?
It was easy, but time.
Oh, the time,
Yeah. 'Cause
2 hours wasn't enough? Okay, yes, this first one should be easy, right? Because it was what is, well, I think it was easy, you know, but. But it's all the stuff that you guys should have, you know, what is a compound, what is an element, what is, you know, all that stuff, you know, solutions, you know, what is a solute, what is a. There's calculations, but there's not a lot of calculations. This next one, which is gonna be happening in about a week and a half, will open up. I know, bam, 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 right? Yeah, the next one. will be hard.
Are we allowed to have like an index kind of like notes?
Oh, if you guys get it, then that means it gets to be harder. If you guys get it.
Oh my God. All right. I'll leave with this.
But we can use the periodic table thing.
You can
Right?
use your periodic table, yes.
Do we have to like pick it up so it's like camera picks it up? That way we're not cheating or something, or what? I'm using this.
Yeah, well, you don't have to say at the end of this, of your exam, what I'd like you guys to do is upload what you guys used, notes that you guys took. I didn't I didn't open it up for you. But there's any of your notes, your scratch work, upload it because,
It kicked me out because I was zooming.
yeah, you can't zoom when you do
Oh,
it.
I didn't know.
Yeah.
It kicked me out, so I can-
Yeah, so it will kick you out if you zoom.
yeah, I didn't know that.
Yeah, because you can't be zooming while you're doing it. You're in the
Like
middle of an
laying
exam.
down. I was laying down.
Yeah.
Yeah.
Oh, yeah, it does. It will.
Wait, so you can't zoom in? What if it's like really small?
Yeah.
Struggle.
Oh, I see what you're saying. You can't resize. You can't resize the problem.
Yeah.
Okay, so I can adjust that. So I can't adjust it now that you've already took the test. So you guys all have to deal with it. You just need to get a magnifying glass. That, you know.
I already have glasses as it is. Hey, Juan, what do we have to do for engineering 10? Yeah. We have the midterm. It's just, he said we had to meet up or something by then.
You said you could.
You could?
Yeah. I think you said it was mandatory.
Fuck. Are you sure?
Yeah, I'm pretty sure. I think it's just like for study groups.
I don't pay attention to that class because
Our
it's 10.
partner,
Huh?
our partner, he gave us the wrong film.
Really?
Yeah, I think so. Because it doesn't let me add it to the group chat.
Oh shit. Fuck. I'm already taking engineering 20. I don't care about engineering 10. Like, he's basically going over the things that I'm doing in 20.
Dude, did you look at the practice test or whatever? Have you
No.
seen it? It's like, they asked him this random question.
That's how it is in 20 also.
It's like saying, what's like what's the definition of engineering? What is that?
But we never went over it.
We never went over anything.
For us too, like in the graphics, right? Because it's there's certain icons that pop up, but you can't go to the icon because your mouse can't hover over it. So it's like, how are you supposed to know what this icon means? And then he's like, oh, well, it says right there. I'm like, it doesn't say it anywhere. Like, it doesn't show the relation to it. And he was like, oh, this line means it's parallel. This one means it's coincided. It's a tangent arc. And it's just like, what?
Next week.
It's a 1 unit class.
I know.
What class is this?
Engineering.
Engineering 10.
It's only 1 unit.
It's 1 unit, but he gives us more homework than what we do for engineering 20.
What is engineering 10?
Engineering 10 is introduction to engineering.
It's not a programming class?
No. That's like later. That's like engineering 40 or engineering 35. Or I think it's also like computer science I have to take also. Well, I'm doing computer engineering, so I have to take computer science.
Yeah.
But I'm taking engineering 10 and 20. And 10 has more homework than 20.
It's ridiculous.
Had only 2 semesters.
Like all of the work or homework that we have for 20, it's literally just classwork. That's our homework. And you can finish it within 20 minutes.
Yeah, I don't understand. Like, why didn't we have to write an essay?
So I said 2. I didn't have to write one for English. Well, that's a lie. I did like for 2 like last year, but still. Like it's English. Adam, the schedule, that one pissed me off.
Schedule.
Because you had to make the
First one?
schedule, yeah. I'm like, no, why?
That the midterm, I think she's gonna guess. But the first question, is in your own words, what is engineering?
I'm just a problem solver, critical thinker.
Those are good answers.
I hope
So
you
in
can
other
tell
words, I'm
him that.
teaching you guys how to be engineers in this class. Is that what you're telling me?
I guess so. I mean, there's huge differences. I don't know if I have midterms for engineering. It gives us same packets.
You give you guys packets as well.
Yeah.
Engineering 10.
Oh, I mean, this thing. And then this is for engineering 20.
Yeah, I was gonna say, I don't think I've done a packet yet. What's the homework? Are you supposed to turn it in online?
No, you never do
Okay.
that. You're never supposed to do that. He gets mad. He yelled at one kid. Like, they're
It's like the
25.
first week.
So this is different. So this is 20, right? This is like design, right? So he asked us really awkward questions and symbols that we can't
Okay,
hover over. And I guess I'm wrong, right? I probably would, right?
Yeah, because I can't even tell what the damn symbol is. What is that supposed to be?
So it's this one, the symbol for 1, right? It's this right here. It's a minus. So what does that mean? I put B. It's a horizontal line.
Okay.
I'm like, what? And so the 2, it would be like that. I messed up again. It's a vertical line.
Okay.
But for 2, I put it parallel because there's one right here, there's another one over there. But
What?
because it didn't point it out to each other, right? That means
Those
it's
are
not
not
parallel.
parallel. Yeah.
And I was like, okay. And then for what? For and I don't know which one was asking for. For the piece one or this one.
Yeah, that would be.
It's coincident, I believe. All right. That's the midpoint of the line.
Okay. Nope. When I got that. So. Plus, it's really hard to see the symbol.
And especially because it's not colored, because
Yeah.
they're color oriented too.
That's right.
Like there's things like, like when you save it into a file, what is it called? We don't look at that. Like we just name the file.
Yeah. Okay, so this is just it's a add-on to this class. Or no, this is the add-on to this class.
So engineering is just introduction. Like if you want to take it or if you need that extra unit.
Okay.
Like if you want to know what engineering is, basically, right? The 20 is graphics, right? You can make parts like this, right? This
Yeah.
was our part that we have to make. We have to label it, make it into this, right?
Yeah.
But this one is.
And you guys are using CAD for this, or you're using?
That's SolidWorks. Right now we're doing hand drawings. If you can imagine the stress that everyone's going through.
Yes, I can only.
It's like, well, it's not straight, it's not parallel. He actually uses a ruler.
Are you
He
serious?
checks it with a ruler.
Really great.
Yeah, and he was like, okay, the circle isn't a perfect circle. You have to use a compass. And this
He's,
is,
he's a really nice guy.
I believe he is. I hope he is. He saw that one of us was cheating and he got really mad.
Yeah.
Apparently we cheated. Apparently.
No, I get mad when people cheat too. I'm not gonna lie.
Of course. I mean, I can understand. But like, let's say we have this, right? But let's say it looks somewhat similar, right? You get mad over it. It's like, well, everything that you gave us for the test,
It was exactly the same.
it's exactly the same, right? I mean,
How could you be upset?
yeah. No. Those poor two kids got a 0.
Were they really cheating?
I don't know. I mean, I don't think they would confess to it if they did either.
Yeah, I don't know how many people do that. And it's also, I mean, we're dealing with a lot of cheating.
Yeah.
A lot of cheating. It's funny, I was teaching materials. And one of my students, he's like, in class, we were sitting there, it wasn't an exam, it was a quiz. He was looking at Che in class because the quiz was from, the book itself. right?
Yeah.
And they have pretty much everything online.
Oh, yeah.
Oh, yeah.
Unrelated question, are you going to check?
Well, I do go on Che. I go on Che to find out how many of my questions are on there. I have one question on there now, so that means I change it every time. That's why I know the one that's on Che is it's always gonna be wrong because then I've changed that question, right?
Yeah.
Yeah. So yes, I do go on Che.
Oh, I thought you had like those accounts to answer.
I do have an account. Yeah.
To answer questions and all that?
No, I have an account that I go and check to see if I have it, and I keep an account just for everything. No, not for me to answer questions. Typically, the questions I give you, I can answer. Occasionally, I get the ones from Chem 101 that are active learning that, okay, that one stopped me, and I'm like, okay, let me think about this for a minute. And then but there's not too many of them that are like that. But I do go to check to find out how many of my questions are. So yes, I do that.
Oh, I thought you were one of those verified people that answer questions.
Verified.
And give you the wrong answers.
Oh, that'd be pretty funny.
Then we verified in the answer questions. and I don't know if it's right or not. So.
Admitting to cheating.
Unless you're not using it, not for this kind of deal. You use it for math.
Nah, see, that's understandable, but math is easier than this.
Because I'm lazy.
Oh, I am too. But I'm not gonna take 30 minutes out of my time to solve one question.
So you're just gonna go to Che.
For
I
here?
don't trust check.
No, I don't use it.
I don't trust it for chemistry.
And now that you know that I have an account, you're like, you're even worried about it now.
I don't submit questions, so if it's not on there, it's not on.
Yes.
What do you guys talking about?
Check.
Cheating.
It's expensive too to buy check anywhere.
It's $14 per month,
You
$14.99.
guys are both pay that much.
Yeah.
I write my rank for that. Seriously. I saved up that money.
Yeah, I have a group of students in last semester in Salinas that were taking intro to Chem. And
Wait.
they have a test bank where they have all of the tests that this one instructor gives, and they have all of the labs that this one instructor gives. And so then when they had me, because I don't do any of the labs that he did, and then they were like, so they were half of them dropped the class, and then the other half that stayed, they're like, they're trying to turn it and say, that's not the lab.
Are classified as.
Yes.
It says 1, 2, 4 for number 1, right? For what is engineering?
Yes.
In your own words, what's engineering? Why is there 4? I figured I would
It's like,
get
like, it gives you 4 different things to
in the
put
library
out.
to make
I'm pretty sure you went over like in the last, but
I
I
don't-
don't even remember that.
I
That's
don't
what you're supposed to look at your notes.
He didn't give us notes.
Oh, he didn't,
He doesn't give us those. He just here's a PowerPoint.
Okay, so we have the class for 1 hour. The entire hour, we're just staring at a screen with just slides. Like, not even writing anything. He just puts the slides on the board.
That's it.
He just talks about it.
He just talks about it. And like last week he was going about like car parts and like,
Yeah.
dude, this is introduction to engineering, not car parts,
Yeah.
not car assembly, anything. I don't understand. I was just even paying attention at that point.
Like the pulleys and
That's
how,
that's not electric.
how they like generate power for it. I
Yeah.
don't know why.
He was going over timing belts and it was like, when you change your timing belt, this is what you're supposed to do. It was
I
like,
don't know
I'm
why
like,
he was
what?
saying
I'm like, this is introduction to engineering.
Yeah.
And he was like, oh, it's like, if you hear squeaking, you gotta make sure to change out your timing belt or tension your timing belt. Or was it the pulley, one of the pulleys?
But he's making an assumption that all you guys are gonna be mechanical. Their program is.
Yeah, it's primarily mechanical and I think electrical.
Yeah.
But I'm not doing that. And it's just like, what?
Oh, I have a
Which
question.
one? I
So
understand that.
I wasn't know how many times we want to meet
I
for
don't
our
see,
final
I don't
project
get what he was talking
and when do we meet, like, a certain day.
Yeah, there are certain things I haven't put them out, they'll be going up.
Oh,
All
this
right.
is why
They'll
we're
go up.
talking about this. He just started talking about it.
And then you
Just went
also
straight
get,
into
Yeah,
get
like-
pulleys.
the assignment itself, the full assignment.
Okay.
That one was funny.
You like being the guinea pig, huh? So
Huh?
you're the
And I'm
guinea
already
pig. They
tired
won't
of it when I
ask,
go into that
They'll
class.
have you
I
ask.
know,
Yes.
I started falling asleep, but just looking around.
Just fucking, I was like, is everyone paying attention to this?
What do you want us to do?
Like, at least like the other class, the next one you're probably gonna take. That one's at least fun, right? You have to make your own art. But
Oh,
you don't do anything in that hour.
okay.
It was easy.
You're not gonna?
Check.
No, he didn't let me.
Check.
Why?
I was gonna do this.
Do like this
That's what
or
we didn't
here's
know.
that.
Why
They
not?
said I had to do 10 first.
I'm doing both.
That's why I'm confused. 'Cause I know people were doing both, but it didn't let me. It kept saying you need to do 10 first.
Oh.
I didn't know that.
You have the math requirement already?
I don't think so.
That is-
You didn't do math 16 yet?
Math 16?
Yeah, or you're supposed to be doing calculus.
I think I'm on math 20.
Yeah, no, it was like.
So you're taking calculus too?
Huh?
You're taking the second half of calculus?
She's like,
That's
No,
what
I'm
I
not-
did.
Yeah,
I thought about it.
You're what? Taking statistics or something?
I'm not taking that. That's the thing.
Because right now I'm taking calc also. Because I think the requirement is math 16A,
A lot of my classes.
and then from there you're gonna take calc.
I was able to do the exam. I just never. had the exam by camera. I'm just gonna do it one of the. Do the exam map today. Yeah. That we use for today. Based on this, say we check in. If the camera reports it. So if you're, yeah.
Yeah.
Yes. Otherwise, he check us and we're using that rather. He says you have, you gotta make a whole look.
No, it does. I think he's
And
supposed
any-
to like.
any coaching plans, right?
Oh, okay.
But you can't have, obviously you can't. Get away from text, but
It's math 40.
I guess you can type that.
That's my concept. They didn't let me do any of the math. You know how on the list is okay, like, oh, for this major, this math.
Yeah.
So I did math, but it wouldn't let me. So I emailed my counselor. And he was like, oh, you have to do
Yes.
this.
Lionel?
I don't.
You got Lionel? You know your
I
counselors?
messaged all of them.
All of them?
They didn't give me one. I just messaged all of them. And so he told me to do O 41 L 2. So I was like, all right.
But like, what math is that?
It's like college algebra for STEM.
What?
That's what he told me to do. So I was like, all right, whatever, you know.
That's why I'm taking it back.
Oh, no, saying if I had to.
Because like, math 16 is
Okay.
required.
Guys, ready to go?
Which is
69
pre-calc.
questions.
Yes.
It's not on there?
You give me like the list of.
So you can go since you've already done.
Oh, thank you.
You can't go. You have to stay. Because I know you're not done.
I know, I'm not doing anything.
Okay. So it says,
Well, I can't see.
Oh.
But mine's different. Yeah. Wait, is it?
Yeah.
I feel like it's a mix.
yes, there's a mixture. You're not gonna all get the same answer. So you guys.
My first question was different.
I know. Okay, so that's part of the thing. You guys are not gonna get all exactly the same answer.
Okay,
I mean, same questions,
that
right?
makes sense.
But they're very similar to each other. Right?
I usually do this.
So I take so fucking long to make these damn tests, I have to find, okay, that looks about the same, you know.
How many questions is it total?
50? Are you- This is 50?
This one is 69. This is practice test. I gave you more questions for your practice test than I gave you.
Okay, just in case.
Because I wanted to make sure that you guys were able to finish it in a timely manner. Even though she tells me that I need to put more time.
Yeah, it took 45 minutes for one question.
Okay, so let's start off here. So which of the following states of matter is considered fluid? Which?
B. Wait, hold on. It's
B.
You said D?
I said B. I said E.
Okay, so everybody say B?
Yes.
We have B and D. We have two B and Ds. Okay, so
Submit it, submit it, submit it.
I didn't even get it wrong with it.
Okay.
No way,
D.
that's crazy.
It's flow in the shape of
I know
Oh.
that's.
They were second guessing themselves, that's why.
Flow, like atoms can move between each other.
Also not compacted.
Wait,
I mean, even heavily compacted gas can be.
That's gas.
fluid.
But it'd be in a gaseous.
Explain why gas considered a fluid.
Okay, it's, okay, now read the question, right?
Responding states of matter considered fluid. Like fluid motion?
Yes.
Oh, that makes sense.
So Juan was right? Okay. A bar of silver is an example of A, element, B, compound, C, mixture. Bar of silver. Say
Yeah.
I'm gonna say
If I'm gonna be wrong, we copy.
Oh, yeah,
Yeah, I told you.
this is a practice exam. You can be as wrong as many
should
times
be
as you
able-
want.
Yeah, and I think if you should be able to do it another time. And I think it'll give you a different set of questions.
Okay, that's kind of.
I think you have to reset the thing after.
Oh, we get to retry like nonstop. Like,
Yeah.
would be refresh. Oh, that's nice.
solid.
That is indeed a solid.
Solid, everybody agree?
Yes, sir. Yeah. Send something.
So which of the following would be a chemical property of a sample of neon gas? B?
So maybe
Anybody, everybody agree?
D.
You said D?
Which of the following?
You said D.
I see D.
And you said B. Okay,
Wait.
I haven't submitted it yet.
Honestly, I don't know. Which one you want? I'm gonna go with them. Yeah, test it.
Okay. How many of you guys say B? Because we have B and D going on. Those who say B, raise your hand. We'll go with the one that everybody put the most in. I know the answer.
I'm
Okay.
going arena.
Juan, you're not gonna vote? You're not gonna vote? You think it's C?
Neon has a clue, right?
Because it's the chemical property. So both the color or the colorless, that would be a physical property. And then also its boiling point is a physical property.
What is it?
What's in her?
Inert means it doesn't react. Remember the noble gases, they're cool, they don't react. Inert means they don't react. I did show you guys the chemical equation. Okay, I have to show my other class.
You should show it again. So picture.
Wait, what? Oh,
Which of the following?
So which of the following is a method of separating a solid from liquid mixture?
Damn, I don't even know. what
It has
some
to
of
be, I
these-
think it's B. I
You
see.
said B, as in boy.
What is-
Anybody else? B, we have B, B as in boy. Filtration,
I'm not sure.
Wait, filtration.
filtration. B as in boy. Or separating.
I'm not
a
too
liquid
sure,
from a
yeah,
solid.
but I don't know what the answer is.
I didn't read the question. Yeah, B.
Think about coffee grinds.
Yeah.
How
People classically brew coffee.
Okay, that makes sense now.
I mean, B, I just.
I can't see.
Is it too small? Do you want me to make it bigger?
Will it kick you up?
Fine. Yeah.
Oh, well, I think it's the last answer.
It says, which of the following is a pure substance that can be broken down into simpler substance by chemical means?
E. That, you did the face that's wrong.
I did not. What
He
was that?
said, what the?
Is that D as in donkey? How many of you guys say D?
It's wrong, yeah.
Okay. How many of you guys say B as in boy? How many of you guys say C as in cat? How many of you guys say E as in elephant?
I'm gonna die on some kind of.
You gonna down the hill? What was that?
Oh, I'm just trying to.
I respect that, I'll go down with that too.
It says, you want me to reread the question?
Yeah, reread the question.
The question says, which of the following is a pure substance that can be broken down into simpler substances by chemical means? Okay, so we have
Wait, let me, I wanna hear
That
this
makes
solution.
sense.
it makes sense now?
So. I can see it.
Oh, I
Okay.
just look at the TV over here.
I keep getting, I can do this one.
It says, which of the following best categorizes the idea that the rate of a reaction is dependent on the temperature, because the rate ultimately depends on the frequency of collisions between reacting species, atoms, molecules, etc. Scientific law, theory, hypothesis, observation.
Can you scroll a little bit to the right? Yeah, there you go.
What do you think?
D.
Yeah, I'd say that theory.
Okay.
C,
Said
yeah.
A or D?
D.
I can see it.
C, A, yeah.
You can see it as an A? Okay.
I am going with A.
Yeah.
Okay, how many of you guys are saying A?
We'll die here.
How many of you guys are saying B? B as in boy. Yeah, two that are B. And then how many of you guys are saying C? How many of you guys are saying D as in donkey? Okay, so I'm gonna put your answer.
Oh, it's wrong.
I'm not saying it's wrong. You see why I can't do this game? Okay, so let's retry. So
What's
what
wrong with
theory?
theory?
I talked to you guys about it.
Let's go to the list.
You said theory.
Hey, it's theory, we know it's theory now, hey.
Okay,
Finish what you're saying though.
no, I was saying, what theory? I should have said,
You're saying theories right now, now we're figuring out-
never mind, never mind. This is like last week, but I kept showing you the answers. Okay,
Wait, but can you explain why though?
Yes.
Yeah, explain why.
Okay. it's considered a theory because one of the things is that a law basically means that that's the way it works all the fucking time. It never changes, right?
Yeah.
It's a theory because there's points that it does change, right? And that's when we start talking about like plasma and shit like that. That starts messing with things.
Oh.
Because part of it might be correct, part of it might be.
That's what I just said, yes,
Oh,
So- yes,
But to me, both-
yes. Thank you for the translation. I appreciate it. So.
So what makes this statement a theory?
Because it's true in most cases, right? So when we're in a certain range, it's true, it holds up true. But then there are certain ranges that it doesn't. And so that's what makes it a theory. So it would be a law if it was true in every case, right? That makes things laws, right? A theory means that it's true in certain circumstances, but there might be these exceptions that happen. Yes, sir. Yes. Okay, let me put the next question up, give you time to think about it. And then I'll go back.
Can you scroll down a little?
Yeah, can you scroll down or zoom out?
Oh, there, yeah, there is a
another
need.
one.
Sorry, do you guys need a knee?
There you go.
I'm going with C because it's the longest one.
No.
I'm just going with C because it's the longest one there. That's
Using
usually
here?
how it goes.
No,
I mean.
It's usually how it goes. It's the longest one.
I'm
Or
pretty
it's the
sure all
longest
these
one.
statements are true for certain different things.
That's a different definition.
But
I'm going
like-
with scientific law right now. And that's the longest one, so I'm going with C.
Is it because you're saying, like, because in your mind, science is long and complicated, and that's the definition has to be?
No, because
No,
it's long.
it's because basically every explanation to every answer is always the longest. That's always the right answer.
Yeah,
90% of the time.
That's true.
A is hypothesis.
Yeah.
That is a definition.
That's small.
So you were saying that cannot be the definition to hypothesis
No, we
because it
said
is
it
short.
cannot be the definition to scientific law.
Why does a scientific law specifically have to be a
Because it's a
long
law, of
definition?
course it's gonna be long.
I hate your logic
But it
But it's
works.
right.
because it's like,
Exactly.
Because if you would ask for a hypothesis, it'd be like if in that statement that can be tested by science, and then it'll add something else completely that does not need to be there.
yeah,
And then that'll be the right answer because it's longer.
it's like your logic is like someone telling you to make the color yellow, but instead of putting yellow, you go put green and subtract blue.
It
Either
works.
way, you win. Either way, you win.
It's roundabout. It's technically correct.
Get the same answer.
As long as the result's the same, I don't think it matters.
It's better because the moment any of the context changes, you're gonna get it wrong.
No,
I
no,
mean-
majority of the time, it's a hit.
Like I look at it.
I want there
read
to be
it.
another question like this, just so you can get it wrong now.
Make me see why.
It's a lot, it's gonna be long.
Someone click C.
Well, I feel like there's something in my spine.
It can be funny, but I don't think so.
Die on the hill.
Then perish.
Yeah.
I think I got an eyelash in my eye.
on so far. I did not. Yeah, we're all getting jobs here. now.
I'm trying to focus on like,
We're all
saying no, yeah.
Yeah, and then we're gonna be doing this.
You are just, I want to scan this in.
Do it. No one's stopping you.
I plan to do it on the list.
My own procrastination.
This is why you could change the word want to like you're gonna do it, yeah. Like how you wanted to buy those fishes. Alright. I encourage, I mean, theoretically. I know.
I'm going to go the way.
Well, the good thing is that
I'm gonna go the way my kids are going.
and then on Wednesday, so I don't want to be engaged. I want to go to class.
They said it was easy, and I built self-confidence.
Yeah.
The exam was easy. I built some self-confidence, but like walking, like after on a break, I like left and like, nah, man, it's gonna be hard.
Yeah.
Kurt, you know, I'm so upset on this one specifically. No, this one little fluff. This one little bit of fluff right here.
Okay, we have
I'm
an
going
answer.
to, I'm going to ignore any of your
C.
mom statements from now on, I swear.
Okay, wait, we have E.
We're all are unifying. on this
Okay.
concept, right?
How many of you guys say C? Raise your hand.
Because it's the longest.
Your logic is flawed, and I'm not going to argue against the C.
We're all-
Okay, and how many of you guys say E as an elephant? Okay, how many? So, I think the C's outweighs the E, so we'll start with C. We'll see.
I don't like that.
We'll see.
It's wrong, it's wrong.
Yeah.
Good job.
My wife is
I swear to God, one moment you are like defeatist, the next you have a god complex.
I do. I foretold that Evan was gonna be asked to join on
So-
Thursday.
A law inside.
I was right.
unifying concept
And they asked
explains
me like,
way
you predicted
natural
it, and
phenomena
yeah, my
occurs.
I swear to God, I'm going to make your god complex into an extensionism complex, or it's like I'm too powerful for this world, I need to be stopped.
It doesn't. That was right behind. It's too close.
I already
That
have
was
a
too
nerve.
far, too. It doesn't necessarily explain why,
It's the wrong flavor of nerf.
why. I'm assuming that's not sad, that's said phenomenon. Said phenomenon occurs.
Alright.
Okay, ready for the next one?
Yeah.
Okay.
I knew this. I just wanted to say it.
A theory. A theory is another word for a model, a law, a measurement, or experiment. So D as in donkey or B as in boy. How many of you guys say A? Raise your hand.
It's kind of listed that.
Okay, how many of you guys say B as in boy? How many of you guys say C as in cat? And how many of you say D as in dog? Okay, I'm gonna say there's probably more A.
Yeah, it looks like it.
And
I know it's not.
wrong,
Yeah.
yeah.
Oh, gotcha.
And theories or models and science.
It's kind of true, but it's not universal.
Yes. The process of filtration is an example of A, chemical change, B, chemical reaction, C, physical change, D, intensive property.
Really quickly, what is an intensive property? Oh, wait, after this. Am I giving
Go away.
away?
Yes,
It's C.
C as in cat.
Yeah. I'd say that.
Anybody disagree?
Well,
Anybody agree?
or disagree?
Well, it's just like, does anybody agree?
As far as the physical change.
I will say, I will agree.
I
This
don't know
one
what
time.
D is, so I can't.
So that basically means that
Exists to give you
it's
trust
dependent on
issues.
mass. Right, remember intensive extensive.
Oh. Oh, that
I don't think that was-
everything. That's what you say. Just because you're removing something. Yeah, you're removing solids from.
Oh.
But it's like what we did in the earlier questions to refresh.
So do you guys
I
think
say
it's
Yeah.
Yeah, I'd say
C,
strong
C,
C,
C as a cat?
yeah.
You to make a
Oh,
face.
yeah,
I didn't make a face. I'm trying to cover it, you know, like, I'm trying to hide it. It's not working all the time.
Here's the way I play poker, because I can't stop smiling when I have a good card, I smile the whole time.
So I have to smile the whole time, that's what I'll do. I won't make a face.
I'm going with D as longest.
Stop it.
So which of the following is not an example of a physical change?
I will go with D.
D,
Because it's so long.
because it's the longest.
Yeah. I didn't even read it.
I hate.
It's right, isn't it?
It's right, I hate it.
Why is dissolving of sugar in water a physical change? A, the chemical composition of sugar changes.
See, because it's the longest.
So you guys say C as in cat. You
Yes.
guys all agree?
Yeah.
Yeah. I like B better, but yeah.
I hate it here.
Okay. Which of the following is the largest volume? And they give you conversions too.
Oh, I wasn't even listening.
Oh, sure.
Yes.
It's a D.
So D as a donkey.
Yeah.
You guys, how many of you guys believe it's D if you guys want a second to your calculations? I have two that are D. Anybody else? I have three that are D. Okay, so shall we select E?
Go down, go down, go down, go down. Oh.
Sense? Convert minus 32.1 degrees Celsius to Kelvin. So 241. Yeah, everybody may have a different.
Oh, yeah, the actual.
Okay.
Because there's some
Job.
stuff that.
Yeah.
Okay, so we know that we just add 273.15.
Yeah.
What is the name of the SI unit for length? I can't believe they didn't even give you. They didn't even make that one. I gave you micrometers, nanometers. Yes.
I'm not confident.
Not confident yet, but you're raising your hand. Tell me.
I think it's C. Not sure.
How many guys believe it's C? It's a cat.
I'll just go with that.
You're just gonna go.
He
with
was,
it?
he was right last time.
Nah, it doesn't mean I'm right.
Last one was the smallest answer. B is the smallest answer.
And this one is the largest.
Uh,
No, that's what it says, the largest. It doesn't say the smallest.
oh, I'm talking about the answer.
Yes. Yeah, let's guys think about it a little bit more.
Just to go. Better than nothing.
I think we have to use.
We're all gonna have similar.
Building bells. So think about basically what he's saying is that you might have one that say has same material, but mine just have this like. Like think of it as this question, your question.
Like the same idea, but just different.
Yeah.
I don't remember that idea. It's from. So, I don't know that. My letter of the day is always been C. It seems.
69, that is a
But then it's point then. Even more so on my own. Well, that's something that's consistent. Right, if you don't know that, start off, just go to C. Guys. I always choose.
Okay, we have answers? You choose C.
We have answers, but we have.
Oh, because I choose a letter a day when I have a quiz.
Choose 11 in a day.
No, a letter of the day. So say,
C is your letter of the day. Okay. So what do we choose? A?
I think.
Is it D as in donkey? So I have one that's D. Anybody agree? Two that's D. 3, 4. 4?
they won.
How many? Well, how
There's
many
like
say
three
C?
There's 3 C's, so.
Any C's? We had 2 C's earlier. Did you change your mind?
Me?
Yeah.
You said C? No, C.
Juan, you're not saying, you gotta vote.
Go with C.
D.
Yeah.
Okay. So I think it's gonna be, it's correct. So let's see how we figure this out, right? So the question. So if we have 4.50 cubic centimeters, so you multiply that times 10.5 grams, right? So then that's gonna give me 40, at least more than 40, right?
Yeah.
Which is greater than all of the rest. So if we go back,
Oh, I see.
so if we go back, this one is already in grams, right? So we don't have to multiply by anything. We just have to look at the mass. So that is 24.5. This one up here, we need to multiply. So we need to convert this into cubic centimeters. So we go 1.8 cubic, and then we multiply that by the density. So then that would give us the mass of that one. And then here, we just multiply this one by, so this one 30, that would be greater than C, right? So we can eliminate definitely not C. And then we multiply this one, it's greater than 10, so it's going to be greater than 30. So
That makes sense.
yes, so pay attention to units. The regular shape of, actually, it's just regular pieces of metal. I've been waiting for those to come in for the last year almost. The regular shaped piece of aluminum has a mass of 50.0 grams. What is the volume in cubic centimeters of this aluminum if its density is 2.0 grams per cubic centimeter?
Right. To be 18.5.
18.5.
Yeah. Yeah. Just using the same road before. That's the equal to. I'm just guessing that.
Three sig figs.
Yeah.
Don't be guessing at sig.
I'm not
figs.
guessing, but I was discerning the things. I can't think of a
That
word.
is correct. 18.5. The density of a substance is its mass per unit volume. if the mass of an object is increasing faster than the volume of an object, what happens to the density of the object? You can put that in
There's increasing.
Density will increase.
density will increase.
Yeah.
Yeah.
You did how you should.
I did not do anything. I was answering a question and I got back to the question. And that's because density is directly proportional to the mass and indirectly proportional to the volume. Other things working on. Let's see. A student has a body mass of 150.5 pounds. He steps on a scale holding a 50.0 pound barbell. Which of the following expresses the combination of the mass of the student and the barbell using the correct number of sig figs?
B.
Is it B?
No. Yeah, no, it's B. Oh, B.
B as in boy?
This would be, I'm gonna have to fix it on that.
That is correct, because it's addition, right?
Yeah.
And then where does significant ends in both cases?
Yeah.
One after 0, one after 5, so. Yes, all the easy questions came up the first time. Let's see, the number 9.41 times 10 to the 5th.
Yeah.
I'll throw that out because I can hardly see it. Guys. When taken out of scientific notation would be C. Okay, everybody agree?
Yeah.
Anybody disagree? Express the number 0.0256 in scientific notation.
D.
D as donkey.
When you say D for donkey, why you say C for cat? Like what happened to the dog?
Because the donkey is so much better than
I will not have this, I will not have this dog slander.
A patient weighs 125 pounds and is receiving a medication via an IV 600 milligrams per 500 milliliters infusion at 20 milliliters per hour per volumetric pump. How many mcgs per kilograms in minutes is being given? 1 mcg equals 1 microgram.
Never like this question. These questions are hard.
This one is the one that just.
Really? Okay, so what am I gonna do? Let's break it down.
So many
Oh,
times.
So we got one patient.
Yes.
One patient weighs
125.
Translate to kilograms.
Okay, so when you change our weight to kilograms, so that 125 pounds. That's gonna, how do I change that to kilograms?
Divide or multiply with 1.6.
I thought it was.
Or
Well,
what
it
was the
depends.
question?
It depends on the units that you're, how you're gonna do it. Right?
Yeah, you're right.
Says that 1 kilogram equals 2.2 pounds, right?
Yeah. 2.0. Yeah, yeah. Oh, I see.
Okay, so then pounds cancel out. That's gonna give us our kilograms.
56.6.
Okay. So what else?
Wait, no, it's 56.47, right? 7.
3 sig figs.
Yeah, so 56.7.
Okay, so that's how much that one prick.
Oh, we used 2.2? What did I, wait, I just shake up, just put 1 point quick, like. I put the 0.5. Yeah.
125.
Yeah. So I did,
At the 0.5
125 divided by 2.205.
They
It's
want to
close
use that.
enough.
Alright.
Yeah, it will be close enough anyway. Okay, so in other words, the patient is gonna be 56.7 kg at the bottom, right? Okay, so what else do we know?
He's receiving, yeah, that, what he's receiving? Yeah.
Okay, so he's receiving medication via IV.
Yeah.
It's 600 milligrams per 500 milliliters. Okay, and he's receiving it at a rate of
20 milliliters an hour per hour.
okay. So we need to go 20 milliliters for 1 hour. Okay. And then, so milliliters are going to cancel out. Now we have milligrams per kilometers, but we want it in micrograms. How can I change milligrams into micrograms?
Figure out how many micrograms goes. I get what you're trying to ask, but I don't know how to put
What was
it.
that?
I think it's 100 micrograms of 1 milligram.
Yeah.
I thought it's
No, it's 1,000.
1,000.
1,000. 1,000. So we have for every 1 milligram, it'll be 1,000 micrograms for MCG. So milligrams cancel out. And now we need times and minutes.
Oh, 60 minutes in 1 hour.
60 minutes
So
in 1
that's out
hour.
of 1 hour, right?
Okay, so 1 hour on top.
Yeah.
Got 60 minutes on the bottom.
It counts out 1 hour.
And then the hours are going to cancel out. Okay, so then we're going to end up with MCG kilogram per minute. Okay. Justin, did you have your coffee this morning? Okay, what do you guys get?
I'm about to do it right now too.
Or.
You put 100 in,
I
it's 2,000.
Did I put 100? It's supposed to be 1,000. Oh, sorry.
I think I got it.
Thank you.
I know I got 4, but I don't know if that's,
And I even said that, didn't I?
alright, so that's 40. Yeah, 40? Yeah, I did an extra there because he just said.
Yeah, so that should be 1,000, not 100.
40?
Yeah, 40?
Yeah, I knew.
Yeah, I
I
had a feeling I got something right there. Oh, no, I see my mistake. Never mind, I see my mistake. I see my mistake. I see it.
1,000
I see it.
divided by 5, 6, 7. 60.
Oh. Alright, it's 57, yeah.
What you guys got?
Yep.
See?
Oh, you forgot to, oh, yeah. Yeah. Wait.
Yeah, I saw my mistake. I forgot to add the.
Did I forget to do something?
The
No,
thing was like invisible to me right there. I got broke. Easy peasy.
Solution.
So let's see.
Okay, so that's clear. See, a pediatric patient with a body mass of 65.0 pounds is prescribed propred. Pronolol. What is that?
Isn't that dangerous to the body?
I don't know. I have to take a look. It's, but it's an alcohol, but it's an interesting alcohol. All. So I'll have to definitely take a look. For the recommended dosage is 3.0 milligrams per kilograms per day. Given in divided dosage every 6 hours. How many milligrams of propranolol should be given for each dose?
how many is 65 pounds per kilograms?
So we need to change 65 pounds.
I got 29.47 kilograms.
At how many kilograms?
29.47 kilograms.
2.2 pounds per kilogram. 29.2.
29.47.
47, so 29.5.
Yeah.
3 sig face. Okay. And then what else?
The recommended dosage.
So then we multiply that by the dosage. So 29 kilograms. milligrams per kilogram per day. So kilograms cancel out. Okay, so then that gives us,
Then we need, since they're asking for every 6 hours, we need to put in an hour, right?
okay, so it's- so we need to change.
So how many doses would it be in one day?
So how many hours are in the day? Okay, so we go 4 hours.
Or, yeah.
Okay, so 4 dosage a day.
Yeah.
So then we take this number, whatever this number is, and divide it.
Yeah.
Oh, 88.5.
Yeah, so this is 88.5,
Yeah.
and then milligrams. Okay. We divide that number by 4.
Yeah.
So some of you guys get.
22.25.
Yeah.
So how many sig figs should I have?
2.
So 22. Okay, let me give them the next problem. So is it good news or is it bad news? Should I start crying now? Okay, he delayed, so then it's not good news.
It's mixed.
Yes, yes, exactly.
Okay, here's another one.
Like, can I like scoot it to the right?
Is that better?
Yeah.
Micro, it's a micro.
It's in 1,000.
I don't know, okay, micro.
Oh, no, I
Oh,
did.
you gotta take notes for it. Yeah. So-
One.
Yeah.
Oh, you did check.
Yeah. This one. Yeah.
Now they're getting a test on this.
Yes.
Crazy.
About 10 weeks later.
Just one.
Because he has food, it's very, very short for him.
Oh, I don't even know how I got it. I just know I got it. Oh, that's what he said. I don't know. Or those previous-
I don't know. I don't have cancer.
No, you divide it by 4 because.
Oh,
we
it's
multiplied
like,
it by
except for the big plates.
I don't remember how they look. I didn't write any of it down. but I-
Yeah, no, yeah, for sure.
So you divide it.
Yeah,
Yeah, by board because there's he has to take the notes board test. And every that he takes the Joseph with it every 6 hours. So imagine like 6 to go to 24. No, it's every 6 hours. It goes 4 hours.
Yeah.
Let's make one of those.
Yes, sir.
It's a lot of you. I mean, I'm down to learn, but
Yeah, no,
I don't
for
want
sure.
to. I don't want to. Yeah, right. I did actually, yeah. I don't know where. There's- Oh, no. I think I wrote it all down. Yeah, I wrote it either. here or that.
I also have to take up
Then it's the-
my mom can get to it.
or-
Okay, everybody got answers? No answers? One? You guys, answers one? Okay. How many sig figs? Half.
2 6.
Yeah.
Free.
Yeah.
You gotta look at that.
Yeah, just to make sure. You know?
Is this helpful?
Yes. Oh, yeah, yeah.
No,
yeah.
for sure. So we have 2 people that said it for sure. I should give you guys a practice test. I'll save it. I won't make a practice test if you guys don't want it. Nobody said, well, no, I said, you guys didn't say anything. To me,
That is a no.
yes, a no answer to me is when you don't say anything, that means no, right? Because that's what my boss is. If they don't give me the answer, and I do what I ask them, or I tell them, I'm gonna do what I'm gonna
For
do.
me, it's opposite.
What was that?
Yes.
It means yes.
When my friends didn't give me an answer, I would always, so it's a yes.
Okay, so vanilla to micro. What did we talk about this a second ago?
It would be.
So what is the conversion for a micro? Or how many micrometers or microliters are in a micro? How many liters are in a milliliter? 1,000. So 1 milliliter, 1,000. What is this?
The symbol for micro,
Mu.
like, it has a sound behind it. I don't remember what it is.
Mu. Mu. Yes, it still is commonly used when you're talking about small volumes in sciences.
I
But
mean, like,
in medicine, they use MCG.
I mean, in written language, if it was part of a word.
Not familiar with that.
Just showing you.
I'm going to give a different letter.
Yeah, that just makes it.
There's discontinued.
What was that?
On the solution, on how it showed its method, it made it less,
I think there's a letter that has a.
but it's just showing it from like the very, I guess, basic point of view.
Okay.
But the, you know, from how we found out, it did make it.
How we did it?
No, how we did it was more simple, like, in comparison to.
Oh, because they went from a liter
Yeah.
to, yeah. But sometimes when I'm not thinking clear, that's I'll do that. Okay, I remember it's much. I remember everything. You guys got it?
Yeah.
We can't pull a little plastic thing.
Okay.
It's really in there.
So renting a car which is reported to achieve 10.1 kilometers per liter. What is the mileage in miles per gallon?
Or you have to for liters and some gallons or gallons. Miles.
Just the mile?
Have you seen your answer yet?
How many miles?
Victor, honey, you got a hammer?
There should be one in this drawer here.
I just checked.
It's not there. And I don't know where it's at. You may want to check the back room. It's in that front drawer. If it's not there, then check the back room.
Okay.
So 1 kilometer equals how many miles?
Oh, it's on
1
the
kilometer
version.
is 0.6.
Actually, it's the. Furthest one.
So 6 kilometers are gonna cancel out.
Where I found it was on.
Oh, I see. Oh, I'm blind.
And
They're
then
kind of famous.
how many gallons are in a liter?
Well, there's 1 liter equals 0.2. Yeah.
0.26 for
Yeah.
gallons.
Yeah, 0.26.
Or 1 gallon is equal to 3.7 something. 754. Okay, what do you guys? So 23.75 exactly.
No, 757.
Okay, so then 3.8.
Huh? Yeah, that's it.
Make me worried there. Your things. The breaking.
Now they're celebrating their accomplishments. That's it.
Oh, that's what it is.
Yeah.
Yeah, let's hope. He comes back out here. I need you for a minute, then I know. Or if I hear them go out the side door, then I know again.
Oh, no, they're just trying to go like how accomplished and how of a perfectionist there. There you go.
You're definitely the grass is green.
Oh.
Okay, why do you guys hate the drag and drop? That's the best part.
That's
This
literally the worst.
makes it super confusing.
Yeah, it does.
Okay, so we're gonna start with pounds.
Yeah.
And you're trying to figure it out in kilograms.
Okay, so we
But
got
I wouldn't
kilograms.
even.
So
notice,
then
like,
that
how
means that we have
something
kilograms on top.
Oh, I
Pounds
always
on
used to put it
bottom.
in the bottom. See, that's probably.
1
Yeah,
pound
that's
per
right. Because
hour.
pounds can just cancel out, right? Okay, because remember, it's the one you're getting rid of is the one that goes on the bottom.
Yeah.
Yeah. Okay, and we know that 1 kilogram is 2.2 pounds. Okay,
And then you have to put equal, I think. Yeah, you go.
and with kilograms. They were clapping, so that's a good thing. Okay,
You
so,
just divide that, the top blue,
so I'm gonna guess the it's gonna probably be this.
that looks about right, yeah.
Okay. How long did it take you guys to realize that you can drag and drop?
Sorry, what?
How long did it take you to realize that you can drag and drop?
Wow. You can click it, and sometimes it'll put it.
Oh, really?
Sometimes, yeah.
Okay, which of the following elements is not represented by a single letter element symbol? Sulfur, iron,
Yeah, it's, oh,
uranium, tungsten, hydrogen.
which of the following?
How many of you guys say sulfur? Raise your hand.
Hydrogen.
No.
Yeah, we're looking for not a single letter.
Yeah,
Iron.
iron. Yeah.
Iron.
I know, but tungsten, wait,
Tungsten's
it's
W.
W, yeah, tungsten's W now.
Are they gonna be like sneaking in?
Why is
some,
tungsten double?
It had another name before, I think it was called warium or something like that. Warium or something like that before. So,
Right.
and that's the reason why. That's kind of like potassium is K, right? And it's it used to have another name.
Which one was called stannum?
Which one was?
Called stannum.
That is 10. Yes. That's SN.
Oh, that makes sense. Wait, is there a reason why they
Yeah, there we have to take. I took a course in the history of chemistry or something like that. So,
Yeah.
Teach one like that.
yeah, it's one of those courses that
I would love to learn history.
it's you take history classes that are not here. So.
Dr. Henry, you know the reason why they dropped say you give an example like potassium is like here. Like, you know why they dropped it off like for further elements? Because like most of them, like ahead of it, is not just followed by like the first initial, the name of whatever they choose, like Dubnium, it starts with an A. Well, in the previous elements,
Yeah.
like how you said, like the potassium.
Yeah.
But you know what's the reason why they stopped dropping?
Um, I think it was because they also needed to not run out of letters, right? Because you need an option. So yes.
On the test, are you gonna like ask us like the original name of certain elements?
No, I tried not to ask any of those. Yes.
Okay.
Yeah. No, because I don't expect you guys to know that. That was the reason I know that is because I took that class, right? And for some reason it stuck in my head. But like I could tell you like 4 of them, and then but other than that, I don't know why. It's like copper, right? Copper's not Cu, right? It's Co, right? So you assume that you would use Co, but copper used to have another name as well. So it's like Cupertinium or something like that. Okay, so which of the postulates of Dalton's atomic theory of matter is/are not true?
B.
B.
Or is it? Remember you guys said before,
I did.
and I think it was, yours was all of them, but. I'm not sure.
Yeah, mine was. It wasn't all of them.
Most of them.
Okay, so let's read it. So number 1, atoms of a given element are identical. Number 2, atoms are indestructible. Number 3, atoms combine in a single
then D.
simple ratio to form compounds. Is that
D.
you said D?
What qualifies as destruction?
In other words, it can't be broken down if it's indestructible.
Oh,
Oh, you're saying structure? What qualifies as structure?
No, what qualifies as indestructible?
Indestructible meaning that it can't be broken down.
No, wait, into
It's not.
individual parts or just broken down in general?
It can't be broken down.
I'm about to.
I think it's just A.
I think it's just A.
Yeah.
Okay, we got one person saying A, we got two that are saying D. Anybody else?
I think.
They said D as in donkey. Okay. Okay, it looks like D has the vote. We have 3 votes, 5 people who voted. Correct answer.
All right, you're the messiah. All right, you're the messiah.
Because the strike atom then means nuclear fission.
That's right. And so you could break it down into protons, neutrons, and electrons, right?
But I couldn't.
Okay, so that means number 2 is incorrect because it can be broken down to protons, neutrons, and electrons. And then number 1 is incorrect because we know we have isotopes.
I was thinking about carbon 12 and corporate 13. That's why I was like.
Good answer. Good thought. Okay, so which of the following statements about subatomic particles are true? Protons and neutrons have charges opposite signs but the same magnitude. Protons and neutrons have about the same mass. 3, a neutral atom always have the same number of neutrons and electrons. So which one is true? A, only 1. B, only 2. C, only 3. D, 2 and 3. E, 1 and 2. Said 2 is correct. Is that the other one? So you'd say B. B.
It looks clear. Because it's on a projector.
Okay, we're looking for the one that is true, right? Which one is true? So which one of these statements are true? We'll just put true by it. Is the first one true? Is statement 1 true? Protons and neutrons have charges of opposite signs but the same magnitude. Is that true? Okay, you say it's false and you say it's true.
I think it's a false prophet. It's a. I mean, you got like 3 in a row.
We're not, yeah, I don't know.
Was that?
I was just saying you got 3 in a row.
Yeah.
We're not, yeah, I don't know.
Okay, so is the first statement true or false? We have false over here, we have true over here. How many of you guys say the first one is true? Raise your hand. Protons and neutrons have charges
Oh.
of opposite signs but the same magnitude. That is not right.
Yeah, right. Yeah.
Okay, so that one is false. Okay. Protons and neutrons have about the same mass.
Not always true. If I'm right, I don't think it's not always true.
Okay, it says protons and neutrons have about the same mass. You guys say it's false? What you gonna say?
It's true. It's true.
Okay, okay, Uncle, what'd you say? Is
They
it
have
true?
about.
Okay, how many of you guys say it's true? Raise your hand. I got, okay, so, okay, so I'm gonna say, I think true's got
It's
it.
like 100 or like a. Let's go with that. So we'll be true like 100.
Okay. Okay, now they said the same mass, right? Okay, so that's the key. They didn't say the same, they said the same mass. It's about the same mass. That's the. Okay, so the next one says a neutral atom always have the same number of neutrons and electrons. How many of you guys think it's true? How many of you guys think it's false? Okay, so only 4 people again voting, so I guess I'm gonna say it's false since. Okay, so then you guys would say B.
Yeah,
based upon what we see?
yes.
Okay. Correct answer is B. Yep. Okay, let me give you guys the next question. I'll be there.
Are you?
You stole my goal.
Yeah, I'm just waiting for those questions on the test.
Honestly.
So I definitely gotta take those off now.
No, I mean, they're incredibly difficult. I mean, We're it's learning experience.
Silver?
I don't know if it is, but I'm assuming it is.
Let's see.
What do you have?
Is it? Cadmium?
I'm pretty sure California.
Yeah. Fucking nothing. No, hell no. No, we have a lady.
Oh, I see that.
Germany.
Well, yeah, but that's the whole country. Or a state.
Yeah.
It's one thing for a country to have an official.
No, we can, no, we're saying like it's.
It's another thing.
They have Japan. Yes.
Yeah.
Yeah.
Fucking God.
It's 113. Deconia. Japanian.
They really like she's at
Livermonium, I think it's Liverpool.
Moscow.
That's Moscow.
I guess this would be sent personal notes, yeah. I have it.
I mean,
Broken up.
I wonder if cadmium red is called cadmium red. Is cadmium usually used as a red dye? And if so, iron also works, no, wait, no, yeah, iron also works as sort of red dye, because that's why your blood is red. It's iron based.
When we would like
trash days, I just realized.
Have you ever heard of horseshoe crab blood? Horseshoe crab blood? Blood of the horseshoe crab.
Ah,
It's blue.
yeah, I know.
We have iron-based blood. Horseshoe crabs are copper-based.
I don't hear a word you say about Canada. I feel like you're right. I'm very confident.
No, it's just something cool that I knew that I remembered about.
You know the 3 types of rocks?
Rock, and rock.
Sedimentary rock?
Igneous rock.
Fucking hell. That is information you do not need to learn.
That was easy.
But it's so like niche. Why do you get to learn about rock?
It's niche. The
Yes.
3 types of rocks
They're
are niche.
they were all
Like,
like
okay.
rocks.
Do you know what the 3 types of rocks are?
I don't know. If the top of my head. I have to look it up. But,
No, that's not.
am I supposed to know the 3 types of rocks?
Right, that's what I'm saying.
So
They know them, but I'm like,
Yes, tell me the 3 types of rocks.
There's igneous, sedimentary,
And
and
igneous sedimentary, and I think it's
my greatest thing is starts with the G. G?
I don't think
But
so.
I might just be thinking
I
about
don't
it.
think so.
I know it's like lava, and then
Okay.
it's like
So are you
Lava is
guys
igneous.
ready for the test?
yeah, and then there's sedimentary that's like buried.
No, sedimentary is.
Right.
Compressive, but it depends on
Look at the rock cycle. I know I'm missing it.
You can use your, yes. Everything that's in.
Like, you really need to learn about rocks.
Metamorphic.
Metamorphic. Yeah,
Yes,
because
don't
apparently I
forget.
need that.
She says, they kicked her out because she was zooming in. It won't allow you to zoom in to the exam, resize to the exam.
Wait,
Was
so
that-
what do you?
It won't allow you to zoom into the exam. Like if you want to make it bigger, right, it doesn't allow you to resize the screen. It'll actually kick you out. But then you can re-enter. I have it set up so that you guys.
Do you want my math scribbles for today?
Yeah, but
Question. Are you guys ready?
Yes.
Now.
Yes,
So I will extend the homework assignment till this weekend.
Delicious.
Yeah, that'd be really cool.
Okay, but that doesn't mean that your other homework assignment is not gonna change, so you have twice the amount of work, so.
But we have
That's
twice the
fair,
amount of
that's
time.
fair, that's fair.
Okay, so let me adjust that now, don't forget. I will see you guys on Wednesday. Good luck.